Alright, so welcome to a new tutorial series of mine. This is going to be about teaching Kotlin as a programming language, and it's going to be very relevant to Android development. And this is more aimed towards people who are still using Java, although if you have no prior experience to programming, that is fine as well. But I'm going to quote Java quite a bit because I find it so relevant, and honestly, I don't think I would use Kotlin so comfortably without Java. And most of the documentation I read is in Kotlin now, but every time I find a clip in Java or whatever, I know how to translate it to Kotlin because it is so straightforward and it reduces so much boilerplate code, and Google supports it, which means it's definitely worth learning if you are using Android Studio and you want to create native apps for Android. But enough said about Kotlin and why you should learn it. Let's just jump right into it. We're going to create a very simple program. It's going to ask you what's your name. You're going to be able to input your name, and it's going to say hello, your name. The first thing we want to do is create a function. So to do that, we're going to write function main, and every project requires a main function. This is where all the code gets executed. And in Kotlin, you don't have to create a class. It's auto-generated for you. In Java, you would have to have a class above it. And this is the exact same equivalent to having the Java public static void main string arguments one, but we don't need that. So let's just continue with the Kotlin version. So in here, the first thing we want to do is write print line, which might look very familiar to you if you've used Java before. And if we actually go to the documentation, it's going to tell you right here, it is exactly the same as the Java version, but it's just shortened down. So it's system.out.println. So Kotlin really likes to reduce code in many respects. And inside here, we're going to ask, what is your name? All right, and right under there, we're going to write value name equals read line. So essentially what we're doing here is creating a value that's named name, and the read line method just takes the user input and puts it into the value. And I'll explain later what a value is in the next video, but for now, just copy down what you see. It will become very clear very soon. And then we're going to copy the statement from above. It's going to be print line, and we're going to write hello. And using interpolation, we are going to write name and exclamation mark. And then all you have to do to test the program is go ahead and click on the plain button and write on run. Alright, so down here it has successfully printed what is your name to the console. Down here it's just asking for input, so I'm just going to write James. And then you click enter and it's going to say hello James. So essentially it was just waiting for your user inputs, and it just added your name down here because this value name was used for this string. And you successfully created your first program in Kotlin. Okay, so in our last video we created a program that would ask you for your name, it would let you insert your name, and it would print out hello, your name, exclamation mark. And in this video I'm going to be explaining essentially the difference between a value and a variable, what they are and what they do. And it came to my mind that in my last video I didn't really show you how to create a project, and that could be quite essential if you're new to programming. So let's just get started in the IntelliJ IDEA by going to new project. You'll get greeted with this nice screen that says Kotlin. You want to check that. Then you want to click next. Then here you can assign a name to your project. So I'm going to do lesson 2. I will write on finish. We will open it in this window. And then as soon as it loads, you'll have this empty project where you can click on this package over here and right click on the source and add a Kotlin file, which is just going to be named main. Then of course every project needs a main function so that it can actually execute some code. And now we are exactly where we left off last time. So the first thing we're going to do is create a few variables and values so I can quickly explain the difference. So the first one's going to be a variable of item, and that's going to be of a string which is going to be called hammer. And one thing you need to know about Kotlin is you do not need to explicitly decide what kind of data type it is. It does that automatically for you, so it will know that this is a string without explicitly writing string. For example, if you want to explicitly say it's a string, you can write var item2, and you can write of type string equals hammer. And it's exactly the same thing, but that's really beautiful with Kotlin. It automatically does that for you. But anyway, that's of our item, which is called hammer, and then we're going to write value fruits, which is going to be of apple. So far as you can see, they look quite similar, with the exception that variable can be changed later. Value will not allow you to change this anytime in your program, or else you will get a compilation error. So for example, if we want to write down here that we want to change the value of item to caret, the program will be happy with that. You can print the caret as you wrote earlier. All right, let's do print line. There we go. It will allow you to print the caret, which was previously initialized as a hammer, and everything will work fine. But when it comes to value, you can't write fruit equals caret. It will not allow you to change it because value is pretty much the equivalent to the final keyword in Java, which means it cannot be reassigned. And this is good for having pretty much values that you don't want to change at any time. And it's very important to pretty much differentiate these. Usually the compiler will tell you, hey, you don't really need to use a var, you can use a value here because it never changes. For example, let's write var item2 down here inside the function, and that's going to equal caret. And then right under we write print line item2. It's going to give you this warning that says, you know, you've never really touched variable of item2. You can just assign that as a value, and that is fine. You can do that to fix it. So the compiler is really friendly about these things. But yeah, that's essentially all you need to know about variables and values, is that variables can be changed at any time, values can't. And maybe one more example, let's create a value of a number, and that's going to equal, let's say it's something pretty specific. So you want to do pi, so 3.1415. I'm not going to go any further than that. And then down here you want to write, actually the number should equal 5. It still won't let you do that. Not only is it the wrong data type because I changed it to a float here, but it also is a final value or a value, and that is immutable, which means it cannot be changed. And that can save you a lot of hassle if you don't want a value to be changed and you accidentally type it in. And that is the difference between a variable and a value. In the next video, I'll be going over data types, and we'll make another small program using what we've just learned in this video. But thanks for watching the primitive data types, what they are, and essentially what they're good for. The first one I want to discuss is the byte. A byte is made of 8 bits, which range from the numbers of -128 to 127, and that's good for very small numbers. We don't use it as much anymore because our processors are so strong that it's just easy to use int for everything. But back in the day, if you wanted to save memory, this was completely and absolutely indispensable, because I mean, you save a lot of data in comparison to a short number or to an int. And even today, if you want to be extremely precise and memory efficient, you can use a byte. But in most cases, it's absolutely fine just to go to use an integer. And next up is going to be a short number, which is very similar to a byte. It's still quite small, but you can go up to 32,767 and down to -32,768. And it is of 16 bits. So a number such as 200 can be claimed as a short. And you might have noticed that I'm explicitly stating what they are in Kotlin. That is because if I wrote 200 in Kotlin or even 10 in Kotlin, it will smart-cast it as an integer. And for those of you who don't know what smart-casting is essentially, let's just remove this. If you write, let's say you declare a variable and you initialize it with 40,000, it will know that this variable is going to be a number, so it will either call it an int, or if it's very long, it will call it a long. And it will do that for you without you trying to define what it is. In Java, you always have to explicitly write whether it's a short, an int, a byte, a double, or a string. You always have to write that. But in Kotlin, it can smart cast it to whatever it has to be. So yeah, an int number is going to be this incredibly long number to that incredibly long number. I'm not even going to bother to try to pronounce it. It is of 32 bits, and in most cases, this will be the one you will use. But in case you need something a bit extra, you have this very long number, which is known as a long. And that is of 64 bits. And this is a huge number that I would never even dream of pronouncing. But in most cases, this will suffice for most of your projects. Sometimes you need a bigger number, but that's a completely different discussion. And also you may have noticed that you've seen these underscores here, and that's just to make things a little bit more visually appealing. So you can do that in Kotlin. It will ignore that, and it will just make nice spaces for you so you can see how big the number is. So it's nice to use those underscores in these situations. Next, we've got floating numbers, which means you can add decimals. A float is good for 6 to 7 significant digits, so you can add you can create a small decimal essentially, and that is of 32 bits. And in case that's not enough and you want to be a bit more precise, you go for a double. And a double is of 64 bits, which gives you 16 to 17 significant digits, and essentially means you can just add a lot more decimal places. All right, and next up is going to be a char, and a char is essentially just a character of 16 bits. It can be a Unicode character, and sometimes it's only half a Unicode character, but all you need to know for now is that it's essentially just a character, such as the letter A, or I believe you can even insert the number 1 as a character. But let's go back to A. And next we have a Boolean, which has 2 states of being, which one is going to be false and one is going to be true. And it only takes 8 bits, and that can be very efficient for control flow statements. And it's straightforward, it's just as it sounds. And finally, we have a string, which is just a concatenation of characters, and that allows you to create sentences, and is great and is pretty useful for many purposes. But those are the basic types I wanted to go over. These are just good to know. You do not need to memorize these numbers, although it could help in the near future if you want to be very precise with your calculations and your codes. I'm sure there are programmers that will just love you if you pick the correct data type for the right number. But otherwise, int in most cases will just be fine. We're in a very powerful day and age where you can just use int for most things, and it won't really affect the performance of your app, unless you have trillions upon trillions of numbers, of course. But in most cases, int should just be fine. Operators, how to use them, and what they are in Kotlin. So let's get started immediately by going to our function main, and I'm just going to copy and paste in this block of code I prepared. And the first thing to check out is that I created a value of first number and a value of second number, one with the value of 15.5 as a float and a 3.5 as a float. Then I created 3 texts, which one is named beginning, one is named middle, and one is named end. And the first kind of operators we're going to go over are arithmetic operators. And that means the plus symbol, the minus, the asterisk, or the multiplication symbol. And we've got the division operator and the modulus operator. And here I just created 5 print line statements that all kind of show you what they do. So the first one is going to say first number plus second number. So it's going to get these 2 numbers without adding them because it's a text value here. And it's going to equal the first number plus the second number. So essentially the plus adds, the minus subtracts, the multiplication operator multiplies, the division one divides, and the only one that will need some actual explanation is the modulus operator. But let's just run this so I can show you real quick what's going on here. So as you can see, the first print line statement is going to print all the operators you have here. And then it's going to get the numbers, first number plus second number, without adding them because I didn't add the brackets. And it will add them here because I did add these brackets. So everything inside here becomes a statement rather than a concatenation of string and values. So you'll get the result of each one. And now here, as you can see, the modulus operator, I just want to explain that real quick, what a modulus operator does. It will give you the remainder, what it couldn't divide. So it tries to divide as many times as it can into 15.5, and it ends up with 1.5 because that's what's remaining. And to explain this a bit better, let's just divide it by, let's do 3 by 7. And the answer should be 1 because 3 goes into 7 2 times with a remainder of 1. And that's how the modulus operator works, as you can see there. And the final thing I need to show you here with arithmetic operators is that you can concatenate string, which means if you have one text and another text or a third text, you can add that in a print line statement or anywhere you want just by adding a plus symbol, and it will add those strings together. You cannot subtract them or divide them because that doesn't really make any sense. But yeah, those are the options you have with arithmetic operators. So they work just as normal mathematic operators in real life. But let's get rid of all of that because that was as simple as that. Next up, we have assignment operators. So what I did here is I started by creating a variable of total and I initialized it with 0. And then I'll show you real quick what this means. But as you can see, you see plus equals, minus equals, times equals. And what this means is if you do total, let's make that lowercase, total equals total plus 5. that is exactly the same as writing total plus equals 5. And that's going to output 5 because total is 0. But let's get rid of that. And here you've got total equals total minus 3. So you're going to get the output of 2. Then you've got total equals total times 25. So 2 times 25 is going to equal 50. Then you've got total equals total divided by 5. And that's going to output 10 because 5 divided by 50 equals 10. And then here you got, with a modulus of 3, you'll get an output of 1 for the modulus operator. But I'm just going to click play so you can see all of that happening in real time. So you see 5, 2, 50, 10, and 1. And it's just a neat way to simplify an expression to assign to our value or to update the value. And that's all that there is to assignment operators. So let's remove that bit of code. Next we have something called unary prefix and increment and decrement operators. So the first thing to know is that a unary prefix is a plus symbol or a minus symbol or whatever goes in front of the numbers, which I believe are only plus and minus symbols at the moment. And there's also the exclamation mark that can go in front of a boolean. That's also known as a unary operator. So if you do var total equals 25 plus minus 30, you're going to get minus 5. You can also add a plus here, although that is completely unnecessary because we already know it's positive. And then you've got increments. So if you add 2 pluses or 2 minuses, you'll either increment or decrement the value. So plus plus makes the total go up by 1. So from minus 5, it's going to go to minus 4. And if you do the minus minus, it's going to go minus 5 again. And there's one important thing I need to state is that if you were to add the plus plus at the end of the value, instead of at the beginning, it will increment it after the print line statement. So you will not see the result when I print this statement, but you will see it the next time it gets printed. And I'm just going to play this to make sure I can get the idea across a bit better. So as you can see here, I printed plus plus, which means it should have been minus 4. But since I added the plus at the end, it did not update it yet. The value did get updated, but after this print line statement went through. But the next time I actually showed the value, it showed the updated value. So this just updates the total after. And finally, there's one more, which is the exclamation mark I wanted to talk about earlier. So if you create a boolean, such as variable is working, and initialize it with false, then you can write if it is not working, which means since it's false, it means it's not working, then it will say something doesn't work. And it's just something nice you can add in front of Boolean statements to make it very fast to check if something is not something. And yeah, that's all there is to it. You'll see it says something doesn't work because something doesn't work is indeed false. But let's get rid of all of that again. And next we have comparison operators. And this might look like a lot, but it's very straightforward, I promise. So the first thing we did is create a few variables. One is called number with the value of 10, one is bigger number with the value of 12, and finally I added a random number to spice things up a bit. So it's going to pick a random number between 1 to 20, 20 inclusive, and then we've got a lot of if statements here. So essentially what comparison and equality operators are these symbols right here, the more than, the less than, the more than or equal to, the less than or equal to, the is equal to, the is not equal to, and then you've also got these special ones, which is the and the or operators. So the first one checks if this number is bigger than this number, which is going to be false, and this one checks if it's less, which means it's going to be true. This is going to check if it's more than or equal to, which is essentially the same as this at the moment, but it is not equal to and it is not more than, so it's still going to print false. This is still less than or equal to. If the numbers were the same, it would still print. And this is true because number 10 is still smaller than bigger number. Then this one you have if number is equal to bigger number, which is false because 10 is not equal to 12. And do not confuse this with the assignment operator, because the assignment operator creates the value. It essentially initializes the value and assigns a new value. So you cannot use this for checking. This checks if the numbers are the same. So these are not the same, so this will not print. And then you've got if number is not equal to bigger number, then it will print because number 10 is not equal to number 12. And for these final two, we've got the AND operator and the OR operator. But let's start with the AND operator. So what it's checking is if these two statements are true. They both have to be true for this print line to be executed. So number is less than bigger number, which is true, and number that is less than random number, we still have no clue yet because the random has not generated a number for us yet, so we have no way to tell. So this might get executed or it might not, we have no clue yet. And that's what the AND is for multiple statements, and you can actually have many of these. You can do another one after that as well, but for this video I'm just going to use one. And finally we've got the OR operator, and this checks whether a number is less than the bigger number or the number is more than the big number. So if any one of these two statements are true, it's going to print this line. And this is a very useless statement because number is always going to be either bigger or less than bigger number. I mean, I guess the only exception can be if number is equal to bigger number, but that's never going to happen. So preferably you'll have this OR statement when you want one of two conditions to be true for this to print. All right, and finally we have the IN operator. So to get this started, I created a var named numbers and I initialized it as a list of 1, 3, 10, 20. And then we had another declared variable, which is random number, which gets that 1 to 20 and picks a random number from it. And then I wrote if random number is in numbers, that's the new operator I'm introducing here. So if one of these random numbers is found in this list, it's going to print this statement. Otherwise, it's going to say the random number is not in the list of numbers. So if we click play, we'll find out whether that random number is in the numbers. And I don't know what number it picked, but that number was not in the list, so it will not print the first statement, but it will print the second statement. You can also do the opposite, which says if random number is not in numbers, the random number is not in the list of numbers, it will print that statement. And that's just a quick way to add the negation to an IN operator. And that's all you need to know about operators for now. In the next video, I'll be going over how to convert types such as an int to a long or a string to an int, so you can actually change values depending on your needs. And type conversion essentially means turning a long into an int or a float to a double. It's just changing types, these primitive data types, into other data types. But let's get started immediately by creating a dummy project. And we will start that by writing a print statement, which is going to say enter a number. And right under we are going to write value number, and we are going to assign to it a readline expression, which is not null. This asserts that it is not null. We'll talk about that later. And we will write toInt because readline takes a string as an input, and we want to change that to an integer. And then we're going to copy these two once again, and we're going to add it right down here. We're going to write enter another number, and here we're going to write number 2. And then we're going to write one more print statement. This is going to be called print line, and it's going to take our first number. So we're going to interpolate by adding this $, and it's going to take number plus number 2, and that's going to equal, we're going to interpolate again, except this time that we're going to interpolate the entire expression. So we're going to add the $, and the curly brackets. This is so everything inside these curly brackets is going to be read as an expression, and it's not going to be converted into a string. So let's just write number plus number 2. And if we click on play, you'll see it will ask you to enter number. So let's enter 5, and then let's enter another number, which is going to be 7. And it's going to tell you 5 plus 7 equals 12. So that's a very simple way to convert a string into an int. But now this is probably where you will encounter most of your first errors. For example, if we enter the letter A, it's going to give you an exception that this number format exception, the input string cannot really be converted to an int because the letter A is not a number. And we will talk about exceptions later and how to handle them, but just keep that in mind that that is absolutely normal when you have user inputs to have users try to input the wrong data type. But let's just close that and we will continue. So we will actually delete all of this because this was just for the example of how to convert a string into an integer. So let's try another example. We're going to do value number equals 1 million. And we're going to create a second value, which is going to be number 2, and this is going to be of type byte, and it's going to equal number 2 byte. This is just another error I wanted to show you, that if you try to convert some number that is much bigger than a byte, or you try to convert it to the wrong type, sometimes it will allow you to do that, but you will end up with weird results, such as if we just print number 2, for example, and we click on play, you'll see that it will print 64. So it took this number million, it converted it to a byte, it did number 2 byte, and it gave you an output of 64. That's because the program didn't really know how to handle that since it was such a large number. And if you remember from our previous episode with basic data types, bytes are quite small numbers, and anything bigger than a byte will probably end up with an error. Even if we did, let's say 200, you'll see you get this weird minus 56. So keep that in mind when you try to convert types that shouldn't really be converted to that other type, because it doesn't logically make sense. But otherwise, we can do number 2, or we can do text number, which is going to take number and it's going to convert it to a string. This is perfectly fine. So when you do text number, it's going to output a string, but that means you can't add numbers to it anymore, because text number is going to be a string and 12 is just going to be 12. So when you print this statement, you're going to get the text number 200 plus 12. And as you can see, it concatenated the two. Instead of adding 212, it printed the number 200 and it added 12 to it as an extra number. So keep that in mind, that you can change number to anything you want. You can do to int, to short, to long, to big decimal. There are lots of kinds you can cast them to. And that is the basic way to change a number type and to convert it to another kind. But you will definitely see more of this in the future. These are just some very small examples of how to convert the type. We can actually do one more very quick example. We're going to write value total is going to be of type float, and that's going to equal number plus text number. And what we can do is make this very complicated. First thing we're going to do is turn this to a string. So now it's going to try to add a number to a string, which absolutely doesn't work if you want to get a float as a result. So we're going to write 2 floats here to simplify everything. And now when you print the value of total, you should get 400 as a float. So as you see there, it finally converted it to 400 and it turned it into a floating number. So you can see the decimal down there. And it's just an easy way to convert values that the program requires. As we required a float here, all we had to do is write text number to float. So what essentially happened was we have the value of number, which is an integer. We turn that number to a string, and then we turn that string to a float. So that's a lot of converting, and that is the basic concept of type conversion. So in the last video, we talked about type conversion, where you could change an integer into a string or a string into a byte and so on. And in this video, I want to go over expressions, statements, and blocks. I'll also be going over comments, so then you can also document your project as you create it. So the first thing I want to go over is expressions. And expressions consist of variables, operators, etc. that evaluate to a single value. And let me just clear what that means. So essentially, let's pretend we create a value of total, and that's going to be of type int, which equals a random number plus 202 between 1 to 500. So this whole line here is an expression, because all of this code right here evaluates to this one total. So we can use this total later and it will be one value. And the same thing goes for this value of number check, which takes this if statement and it returns a single value, such as either more than 500 or less than 500, depending on what the value of total is. Then down here we have 2 statements, but let's just click on play so you can see what this does. And as you can see, that the total that was calculated here was less than 500. It gave actually 324. So the if statement decided to say, it was not more than 500, so we're going to print out the less than 500. And this string was assigned to this value over here, and that's what we get when we print line it down here. That's why you get total is less than 500. But moving on, let's move on to statements, which are very closely related to expressions. And a statement is essentially everything that make up a complete unit of execution. So this whole line here is a statement, And that's because everything written there creates a line of execution. And down here we've got an expression, which we use later in a statement, because again, this completes the line of execution. This creates a value. And if we click play, you'll see that when we do 2 plus 2 minus 1, we get quick maths. Of course, it equals 3. And this one prints hello mate. But let's get rid of that real quick and move on to blocks. And a block is a group of statements, 0 or more, that is enclosed in curly braces. So 2 examples we have here. One is the function main. It has this block right here, which means from the opening curly bracket to the closing curly bracket is 1 block. And we also got one inside the for loop. So everything inside here is a block. And we've got a var, which was declared and initialized with the value of 0. And then we've got this for loop, which doesn't really matter what it does, but the whole point of this is to show you that this part here is the block. Everything inside here are the block statements. And the next thing I want to talk about is commenting, how to create a block comment, how to create a normal comment. But let's pretend you have to document something such as val item equals 1 plus 2, and then we write print line item. I pretend you had this line of code in your project. Other people might want to know what it does, or maybe even you want to know what it does 5 years after having written it. So something very common for coders to do is to use these 2 slashes and write this code does nothing. And it's highly debated that good code shouldn't need comments, but write as many comments as you need if it helps you remember what it does and write efficient code at the same time. I think that's the best combination you can wish for. And also to mention, there's another way of commenting. There are block comments and there are normal comments. This is just a normal comment, but if you want to make a block comment, you just have to hold Shift Control plus slash and it will comment out this entire line. You can also just slash asterisk and start writing something and then click enter and it will write a comment line, because if you do this block code, you can write as many lines as you want in between and it won't change anything. But if you use this double slash, it will allow you to create more code as soon as you click enter. One more thing that might be confusing is depending on which country you're from, the shortcuts might not work, because I have a Scandinavian keyboard. Sometimes some of the shortcuts really don't work. I think it's designed for American keyboards. But if you go to code, you'll see that there are the shortcuts here in case your keyboard's different. Otherwise, you need to go to file and settings and just change the shortcut to something else. And that's actually all I had to discuss in this video. In the next video, we'll be talking about input and output in Kotlin. But thanks for watching this video. If it was of use to you, please consider leaving a like. Otherwise, I will see you in the next video. Bye. So in the last video, we went over expressions and comments. In this video, I want to go over user input and how to do that in Kotlin. So let's get started immediately by going to our main. And inside here, we can just create first a print statement, which is going to say enter some text. And then right below, we're going to create a value of string input. And that's going to equal readLine, which I believe is a Kotlin method. And that just means it will take whatever you input as a string and output it as a string. So we can just write under that, we're going to write print line. And inside here, we're going to write you wrote interpolation symbol plus the string input. And if we run that program immediately, you'll see that it's going to ask you to enter some text. Then it's going to read the text you wrote and it's going to output it down here. So if we write hello, exclamation mark, it will say you wrote hello. And that's the first way to read text. But if you want to also read numbers, you can definitely enter a numerical value and type convert it to whatever type you want. So you can do 2 int. Let's click on play and you wrote 12. It would say you wrote 12, but this would output it as an int. So you can actually use this value to do some mathematical equations. But be careful, because if you add some text or any symbols that this does not recognize, your program will crash. So it's very important you make sure you write the correct symbols for the correct output. But now I'm going to show you another way to read user inputs and how to prevent the user from crashing the program. So the first thing we want to do is create a try block. And a try block essentially just tells the program to try whatever's inside the block. And if anything goes wrong in there, instead of crashing, it's going to create an exception. And how we handle that exception will be determined by what we write in here. And usually this prevents an interruption in the user experience and how they use the app. So this is very important that you learn how to use try catch. So the first thing we're going to do is create an instance of scanner. So we're going to do value reader equals scanner, and it's going to take the system input. And let's create a print statement, which is going to say enter a number. And after that, we're going to create a value of number, and that's going to equal reader.nextInt. And that means it's going to take our scanner and it's going to be looking for integers, and it's going to read that integer the same way we did readLine, except this is made for integers. And you can use that for next big integer, next byte. There are so many different methods you can use for this. So just pick a type, whatever you prefer. I'm just going to do nextInt for the purposes of this video. And then right under we can write print line and then you entered number. And of course we want to catch this exception just in case the user enters something that is not a number, because if you enter a letter or anything else, this program will crash because it will be looking for an int, and you can't really convert a char or any other symbol to an int. So down here we're going to write print line you did not enter a valid number. And also, so you can understand what this is, we're going to write print line, and inside here we'll write exception, and that's going to be just an E, which is going to tell you what exception it was. So first let's go and click on play, and inside here if you enter the number 12, you'll see it says you entered 12 and everything is perfect. But let's enter something else, such as a letter. Let's do S. It'll say you did not enter a valid number, so it handled the exception in that way. Usually you can add another reader statement that says please try again, so it will just loop this until the user inputs a valid input. Otherwise, it will just also print the exception, which says Java util input mismatch exception, so you understand as a debugger what is going on. And one more example, let's just remove this whole catch statement so you can see the trouble we'll be in if we do not include it. So let's go and click on play. Now let's pretend it says you want to enter a number and you decide to type it instead of just inserting the number 5. It's going to give you this large exception which says the same thing as before, input mismatch exception. And as a coder or a programmer, you will understand immediately that the user tried to enter something that was not a numerical value. It's our job to find a way to handle that. So I always like to use the try catch. And yeah, that's actually all I wanted to talk about in this video. If this video was of use to you, please consider leaving a like. I will see you in the next video. So in the last video, I showed you how to take user input and how to use that for your program. In this video, I want to show you how to use an if-else statement, which can also be used as an expression in Kotlin. And these are control flow statements. But let's get started immediately by creating our first if-else statement. And the first thing we have to do actually is create a number, which is going to be a random number between -10 and 10. And we just have to use the method random after that, and that will generate a random number between -10 and 10, 10 inclusive. And we're just going to write print line random number equals, and we have to interpolate that, of course, equals number, so we know what number it generated. Then we can create our first if statement, and we're going to use it as an expression because in Kotlin you can use if as an expression, which is really great. So we're going to write value result equals if number is more than 0, we are going to return the string positive number. Else, if the number is equal to 0, we're going to return the string number is 0. And finally, it requires an else statement in case none of these two are true. We write if it's not positive and it's not equal to 0, then it must equal a negative number. So we're going to write negative number. So this checks whatever number we generated here, and if it is more than 0, it's going to return the string of positive number and it's going to assign it to result. And it's going to do the same thing for the other two. If it's equal to 0, this turns into number is 0, and if it's neither of the two above, it's going to turn this result value into the string negative number. But let's print line the result. So we're going to do print line result equals interpolated result. Then we can just go ahead and click on play. So as you can see there, the random number generated was 8, so the result was a positive number. And we can also make this simple by not making it random and adding a -10. Then it will tell you it is a negative number. And finally, if the number is 0, a 0 number, where number is 0. And that is the first basic use of an if and else statement. And up next, I'm going to show you how to create an if-else expression that also executes multiple lines of code. And let's get started immediately by creating two values. One's going to be value A, which is going to equal 1. And the second one's going to be value B, which is going to equal 12. Now we're going to create val largest number. And that's going to be an if statement of if A is more than B. We're going to create this block and we're going to write print line A is larger than B. And right below we're going to return the value of A. So the final value that you return at the bottom of an if statement is going to be the one that gets assigned to the largest number. And then we're going to write an else block because it requires it here. And we're going to write print line B is larger than A. And right under we are going to assign B as the largest number. Then at the bottom we can just write print line and do largest number equals, and we're going to type in the largest number. When we click on run, you'll see that the largest number is 12, and it will also execute that B is a larger number. So everything inside these blocks, you can write as many statements or expressions as you want, and it will execute all of them, and it will return the final value and assign it to the value you created up here. Also keep in mind that it is possible to use if as a statement by itself. You do not need to assign it to anything, but of course, let me show you that if we have value A again as 2 and value B as 3, we can write if A is less than B, which is always going to be true. We can write print line hello. So it's not required to use if as an expression. You can use it as a statement if you want. And if we run this beautiful program, you will see that the program says hello because 2 is less than 3, and that is logic for you. And finally, there's one more concept to discuss, and this one's called nested if-else statements. So it is possible to nest an if-else statement, and what does that mean? Now let's pretend we want to compare three numbers. So we're going to do value number 1 equals 1, value number 2 equals 100, and value number 3 equals 666. Well, now we can write a new if expression. So we're going to write value max equals if n1 is more than n2. We will write another if statement inside, and it will be if n1 is more than n3, it will return n1 as the biggest number, else it is going to return n3. And since this is a nested if statement, we still have one more to go for, so we can do else if n2 is more than n3, we will return n2, else we will return n3. So let me explain this real quick. Right here we check if n1 is more than n2. If n1 is less than n2, it will skip this altogether, and it will check if n2 is more than n3, and it will print one of the two results. This is how you use a nested if-else statement, and if we print the results, you'll see that 666 should be the max number. So we're going to do max number equals max, and we will click on play. And here, as you can see, max number is 666. And if we change this to 20, we will have 100 as the output. Perfect. And there's one thing that I forgot to mention, that is, if you want to simplify a very basic if-else expression, you can actually turn that into something that was similar to the ternary operator in Java. And let me just show you what I mean by that. So we're going to write value A equals 12 and value B equals 15. So here we can write value max equals if A is more than B, we can just return A, else we return B. And that's a simple way to simplify an if-else expression. But keep in mind that this only works if you have a single statement on each end. And now if we print line, we'll just type in max this time because I can't be bothered to write all of that text. You'll see that the max number that it will output is 15. And that's all I wanted to show you regarding if-else statements. And if this video was of use to you, please consider leaving a like. I will try to put out a few more videos every day. But otherwise, I will see you in the next video. Thanks for watching. So in the last video, we went over if statements, which can be used as expressions, and that is to check whether something is true or false. And depending on whether it's true or false, it will execute an action. And in this video, I want to go over the when statement. And the when statement corresponds to the switch statement in Java. So it is used to check whether an item is a certain item, and depending on what it is, it will have many different outputs, and it is just used to simplify giving different outputs and executing different actions based on what parameter you put in or what value is given. But let's get started immediately by creating a print statement. So the first one we're going to do is print enter a number, and right under we're going to do value number is going to equal read line, which must not be null, and it's going to be 2 ints. So we need to make sure we enter an integer when we read this line, or else the program will crash. But we're not going to handle that exception in this video. We're just going to enter an int and pretend that we will know to only enter an int. Then we're going to copy and paste this real quick. It's going to be enter another number, and it's going to be number 2. So there we go. And then down here we're going to write print line, and it's going to say enter an operator, and we're going to have plus, minus, asterisk symbol, or slash. Then we're going to write value operator is going to equal read line, and down here we're going to create a value of result, which is going to use this when expression to check which operator we insert. So we're going to write operator, and we are going to create a block, and when the operator is a plus symbol, we can just create this small arrow. With the interpolation symbol, we are going to write number plus number 2 equals, and then we need to interpolate the entire expression. So we're going to do number plus number 2. And then we can go down here and say when it equals the minus symbol, we can go and write another arrow. And to simplify this, I'm actually just going to copy and paste the first one and change them all accordingly. For the first one we want it to be a minus, the second one the third one we want to be an asterisk, and the final one we want to be a slash. And then we need to fix all of these as well. So minus, asterisk, slash, and finally over here, minus, asterisk, and slash. And if they enter something that's a bit funky, we're just going to write else operator is not recognized. And finally, we need to print this result. So we're going to write down here print line, and we can just enter the result. And when we run this program, it'll tell us to enter a number. So I'll go first with 17, and then I'll enter 12. And then I need to pick an operator. So whether I want to divide it, multiply it, or subtract it. So let's just go for multiplying. And it will tell you 17 times 12 is 204. So this is really great for simplifying expressions that need to know which input a user has put in. And it does not have to be an expression. You can actually just take this away, and it can be used as a statement. So you can definitely just write print line in each one of these, but I think it was easier just to write all of this and add print line at the bottom. And that is the first example of how to use the when statement. Now I want to show you a few other ways, and for this I'm just going to copy and paste it in because it's going to be a bit easier. So the next way to use a when statement is to check whether a number is in a range. So this is between 1 and 10 is inclusive, of course. So if we actually run this program, you'll see that it will print this statement down here because 50 is a number in between 10 and 100 inclusive. And that's a good way to check within a range what something is. And then we have another way to do this. If you want to be much more specific, you can actually just set a comma here and here. And of course you need to remove these, and here we'll write 1 or 10. And actually we can't put this here because it's redundant, so we'll put 11. And here we can write 11 or 100. So when A is 1 or 10, it will print line 1 or 10. When it's 11 or 100, it will print 11 or 100. So let's just put 1 here, and you'll see it prints 1 or 10. And you can also use this for strings. So let's pretend you were writing a string like hello or goodbye. And here you will write nice, or you can write bad. And then we're just going to change this to a string. So we're going to write goodbye. And here we can put a response as goodbye, good sir, or cool. So it also works for strings and other values. Whatever you feel like inserting there should work pretty nicely. Here's a very simple bot that just responds to these inputs. And you can create a lot of good stuff with this. So we will just continue on with the final example that I have. And I'm just going to copy and paste it in one more time. So this is the final example I have. So the first thing I did here is create a variable called number, and it has been initialized with the value 1. And then here we have an if expression where we're going to create a variable of x, and if the number is more than 20, we're going to return the string hello. Else if the number is less or equal to 1, we're going to return the number 2. And finally, if it is none of these above, if it's between 1 and 20, we are going to return a list of numbers. And you might be asking, why did I make this so complicated? Well, I'll show you immediately right under what it is used for. So essentially, you can also use this is keyword to check whether it is an int, a string, or a list, or whatever type you want to check. So we can check whether x is an int. If it turns out that it's number 2, you'll have this block of code get executed. If you write when and it says, it's an int, you can also check when that int is one of these two numbers, it will execute these 2 lines of code. So this is just a nested when expression. But it also can check if it's a string, and if it's a string, it will execute this line of code, and if it's a list, it will execute this line of code. So it's also good for checking whether it is a certain type. And yeah, let's run this program just to see what it does. So we entered the number of 1, and it should return 2, which means we should get this print line of goodbye. And as you can see, it printed goodbye. And let's just try to see what happens if we turn it into a string. So we need to put this number to 10, so it's between 1 and 20. And right there we have 1, 2, 3, so it printed all the numbers here. And finally we can check what happens if it is a string. So we're just going to put the number 100. So this if statement will evaluate to being hello. And let's click on play. And there we go. It adds the length of this string plus 1, so you'll get the output of 6. And that is essentially how you use when statements. They can be used as expressions, they can be used as statements, and they are used for saving time. I believe I've covered the major part of how to use the when statement, and I will end this video here. Anyways, thanks for watching. So in this video, we're going to be going over while loops. And while loops are used to execute statements over and over and over without having to manually type them. So let me just show you a quick example, and to get started we're going to create a var of number and assign it the value of 1. And then right under we can do while, and inside these parentheses we're going to write while number is less than or equal to 5. We're going to open up a block and write a print line statement. And inside here we're going to type in line, and it's going to have to interpolate the number. And right under we need to add the number each time this loop goes through. So what's happening here is we have specified a condition for the while loop, and as long as this evaluates to true, this will be printed over and over. And let's just play the program. So we're going to do Shift F10, and we are going to wait for it. And as you can see, it has executed 5 lines of code. That is because each time we go through this line, it increments the number by 1. And once this turns into 6, this will no longer be applicable, and it will stop the loop. Now, it is very important you add a condition that turns this to false eventually, because if we just remove this and we click on play, you will have what we call an infinite loop, and this will go on forever, and it probably will crash eventually depending on your computer. But as you can see, it will print it for quite a while, and in fact it might even print it forever. And we can move on straight to the second example. So let's remove all of that, and let's close this nasty window. So for our final example, we're going to write var sum, and we're going to assign 0 to it. Then we're going to write var user inputs, and that's going to be of type string. And let's just clean that up a bit by using Ctrl+Shift+L. And right under we are going to type some instructions for this one. So we're going to do print line, and we're going to do instructions. And then we're going to click enter, so it's going to open a new line. And I'm going to show you something that you can do when you use strings. You can actually just go backwards, or you can call that an escape. So it's a backward slash, and you just put nen, and that stands for a new line. And inside here, we're going to write type in any whole number to add. Now we're going to click enter again. And down here, we're going to add another escape. So it's going to be backward slash n. And then we're going to write press, and we have to do this backward slash because we want to add some quotation marks. And we're going to write 0 and backward slash one more time, more quotation marks, and 2 exit. And the thing is, if you remove this backward slash, it will get confused on where the quotation marks start and where they end. And after we've printed the instructions, we can actually create this very nice program, which is going to add all the digits we insert. So we're going to write do, and it's going to write print, enter a number, and then we need to get the user input. So it's going to be user input equals read line, which should never be null. And it's going to be sum plus equals user input to int. So this is just going to continuously add whatever input we put into the sum. And it's going to add the sum to the next user input and so on. Every time we enter a number, it's going to just continuously add it. And the next part of this program is going to be the while. So this is while user input is not equal to 0. This will continue to work. And in case we enter 0, we are going to execute the next line, which is going to be print line, and it's going to take the total, and we are going to interpolate the sum. So as you can see, we get a list of instructions. It will tell us to enter a number over and over and over until we type in 0. And once we type in 0, it will exit out of this block and it will give us the total sum. One thing that's very important to note is that the do block will always execute this statement at least once. So whatever you put inside will be executed at least once, and if this evaluates to false, it will have executed once and it will exit. But let's click on play to see what the program actually does. And inside here we'll do 10, we'll do 55, we'll write 900, we'll write -99, and then we can do 17, and we will type in 0 to finish this program. And it will tell you the total of all of these is going to equal 883. And that is essentially the basic use of a while loop or a do while loop. And they are very, very efficient, and it's nice to have them in these programming languages because they save you a lot of time. But anyways, that is all I wanted to go over in this video, and I will see you in the next video. Thanks for watching. So in the previous video, we were talking about while loops and how to use them. Now we're going to look at something that's quite similar, and that is a for loop. And a for loop has a set amount of loops, which means that if you tell it to loop 5 times, it will loop 5 times, and it will not check whether a condition is true or false for the loop to continue. So it's much better for having a fixed amount of loops. But let's get started immediately by starting with a very simple for loop example. So we're just going to go in our main, and right here we will write for I in 1 to 5. We will print line I. And this is the most basic for loop you can create, which means we have this value which gets incremented each time this loop successfully goes through. And it will do that for the numbers 1 to 5 with 5 inclusive, and it will print it each time it loops. So what you should get as a result is a program that says 1, 2, 3, 4, 5 in a line going down. And as you can see there, 1, 2, 3, 4, 5. And there's something that is very similar to that, and that is we're going to write I in 1 until 5. And the difference between the double dot and the until keyword is that until will go up to 5, which means it will not use 5, but it will do 1, 2, 3, 4, and once it reaches 5, it will stop. If we click play, you'll see it will only go up to 4. So 1, 2, 3, 4. And that is the difference between using the double dots and the until keyword. So for most cases, I think it makes more sense to use this double dot because it's a lot faster to type in, and it's a lot easier to keep track of when you can see all the values that are going to get printed. But right under that, we're going to create a line. So we're going to write print line, and we're going to do the escape character with the new line character, and we're going to write 3 hyphens, and we need to put this inside quotation marks. And that's just to create a small break between this one and the next example I'm going to show you. And this is going to be how to use the for loop backwards, which means if we do for I in 5 down to 1, we are going to print line I, and this is going to give the exact same result, except it's going to go backwards, which means it's going to count 5 to 1. You'll get 5, 4, 3, 2, 1 as a result. And if we click on play, you'll see we have the first one, and then we got the line break. And then down here it says 5, 4, 3, 2, 1. Let's move on from there. And to make this actually a bit easier to read, we're just going to remove the line. So it's going to be just a straightforward count from 1, 2, 3, 4, 5 to the right. And just to show you real quick what I meant by that, because it was quite hard to say, it's going to look like that. Now let's copy this print line statement and paste it right under, and we can do our next for loop. And this is going to be how to step or to increment it by 2 or 4 or any number and skip every few numbers. And what do I mean by that? Let me show you right here. So for I in 0 to 100, step 10. And what does that mean? Let's just print I as always. So we'll paste it in there. Actually, this is a very bad example. Let me fix that real quick. So we're going to actually interpolate it and give it a space. And then we're going to click play. And as you can see, it prints 0, 10, 20, 30, 40, 50, 60, all the way to 100 with the step of 10. And you can also do that backwards. So we're going to command and copy that. We're also going to copy this print line divider. And we're going to write 100 down to 0. So it's going to do the exact opposite of the previous one. And as you can see, it is very straightforward how you can use a for loop. Now I want to show you that this also works if you have strings. So for example, if we do val languages, and we are going to equal that to a list of string. And I'm just going to copy and paste a few strings to make things fast and simple. And then right under, we can do for I in languages, we will print each one. So it's print I, and that should be a print line to make things easier. So it will be print line I, and that means it will loop through each one of these at the index of each number. So this is the index of 0, index of 1, index 2, and it will go all the way to the index of 4, and it will print each one of these languages until all of them are printed. And if we click on play, it should print out all of these languages. And that is a very easy line of code to write to get this result. Otherwise, there's one more I can show you, which is val text equals whatever text you enter. And right under, we can write for I in text. We're going to print and interpolate to make this look a bit nicer. We're going to print I. We are going to add a small full stop symbol here. So what you should get is a very fancy alteration of this, as you can see over here, whatever text you want. And we can also expand that a bit. Whatever text you want to enter, and you can make it look very fancy. So what it does here actually is print each letter in the string one at a time. And if we put 3 dots, you'll see this becomes very, very long. And it's really cool that you can do this kind of thing with for loops. And I believe that's all you really need to know about for loops for now. In the near future, we might do something a bit more advanced. And again, thanks for watching. I will see you in the next video. Alright, so what is up, guys? In the past few videos, I showed you how you can use Kotlin and essentially the very basics of getting started with Kotlin. So now I thought it's about time we actually get started with a very small project, and this is going to be a coin flip simulation. And we are going to flip millions of coins with just one line of, not one line of code, but just one block of code essentially. And yeah, it's going to be a very fast and simple project. It's going to cover everything that we've already gone over in the past 11 or 12 videos. And let's get started immediately. So the first thing we're going to do is create a few global variables, and let's create them right now. So we're going to do private var coin flips, and this is going to keep track of the amount of flips we do. Then we're going to write private var heads wins, and this is going to keep track of how many times heads won. And private var tails wins, which is also going to be initialized at 0, and that's going to keep track of how many times tails wins. And then we're going to go to our function main, and the first thing we're going to write is a print statement, which is going to ask the user how many times do they want to flip the coin. So flip the coin how many times. And then we're going to assign that number to a value, and that value is going to be used to determine how many coin flips there are. So let's create that value. It's going to be value number of times, and that's going to equal read line, which must not be null, and it's going to be casted to an integer. And right below, we're going to create a for loop, and we are going to write I in 0 until number of times. So it's going to take that number we entered, and it's going to loop this loop for that amount of times. And inside here, we are going to create a value of random. So it's going to be value random, and that's going to equal the range 1 to 2, and we're going to call the method random right after it. And that's going to generate a random number every single time we loop the for loop. And every time we loop the for loop, it's going to simulate a coin being flipped. So we want to increment the coin flips by 1. And inside here, we are going to write an if statement, which is going to be if random is equal to 1, we are going to increment the heads wins, else we will increment the tails wins. So what's happening here is we are creating a random number between 1 and 2. And every time the number is 1, it will be heads that wins. And if it's 2, we're just going to use this else statement to say that tails won. So there's always going to be a 50% chance and everything. And that's essentially what this random keyword does. You can actually put any number you want in here and it will generate a random number between that. But 1 to 2 is fine for this example. And then down here, we are going to write print line, and this is going to keep track of how many times the coins have been flipped, and it's going to show the user that the screen is loading. So we're just going to write coins flipped, and we're going to put the double dots, and we are going to interpolate the coin flips. And then down here, I'm going to show you something new that you can do with strings. And if we write print line, and instead of just writing one pair of quotation marks, we write 3, you will see that it will add this special trim indent at the bottom. And this is essentially just a free block that you can write whatever you want, and it will stay in the position you write it. And the trim indent just gets rid of the indent that you might find over here. So that is great. So the first thing we're going to do is total flips, and that's going to equal the interpolated coin flips. I will add a space there to give it some space between the previous print line. Now we're going to make this divider, which are 3 simple hyphens, and we're going to write heads 1, heads wins, times, and below we'll do tails 1, tails wins, times. And we'll make another small divider down here. And this is the entire program that is going to simulate our coin flips. And now if we click on run, you'll see you get this dialog that says flip the coins how many times. And we'll start off with 10. So you'll see coins flipped 1, coin flipped 2, coin flipped 3, all the way to 10. It will tell you the total flips, and it will tell you who won and how many times. So this time it was flipped 10 times, heads won 7, and tails won 3 times. And if we go to 1000, you'll see it will generate 1000 coins, and it will have said that heads won 486 times and tails won 514 times. And now finally for the final simulation, which is going to be 1 million coins. So 1, 2, 3, 4, 5, 6, and we've got 1 million coins to be flipped, and we will tap enter. And you will see it actually takes quite a bit of time on my computer to generate all those coins and all those print line statements. But after 1 million print line statements later, we will have had all of these coins flipped, and you'll see the number actually seems to even out in the end. So even though sometimes it may seem biased when you use the random statement, such as that, you'll see heads won 3 times, tails won 9. But even though it may seem biased, as soon as you enter a large number, such as, let's say, 2000, you'll see that it starts to even out, and that the 50% chance in the coin flip stands. And I'm not really a master of probability or statistics, but it's good to know that this random function can be counted on. Although there are even more secure random functions, these should not be used for passwords or any kind of... These are very weak random number generations, but that's a complete different subject. This is good for those basic random numbers. But anyways, I hope this video helped, and in the next video we'll be going over how to use functions and how to save a lot of time using functions. And yeah, thanks for watching this video. If it was useful to you, please consider leaving a like. So in the last video we made a program that flipped 1 million coins, and it successfully told us whether they were heads or tails. And in this video I want to continue with Kotlin as a programming language. And to get started, we're going to be discussing functions and how to use them and why they make life so much easier. So the first thing we're going to do is create a sample function. So this is going to be a user-defined function. Later I'll tell you what the difference is between user-defined functions and functions provided by the Kotlin language. So to get started, we're going to write private function do something. And this function is just going to print a statement, which is going to be I did something. Now this function is not going to do anything yet because we have not called it. As you can see, it's still grayed out, and that means it has not been called anywhere in the program. To make a function work, you have to call it in your main, which means it will be executed as a normal line of code. So essentially this is just a wrapper for lots of code that you can put inside. And the whole point of this is to be able to reuse code later. So if I write do something here, you can copy and paste this over and over and over as many times as you want, and it will continue using the code that you have written in here. So if we play this program, it will say I did something 4 times. I did not write print line, so it's a bit confusing. We will just edit that to say print line. And then as you can see, it printed I did something 4 times. And next I also want to discuss the functions that are provided by Kotlin, such as the square root function and the random function. So inside this do something function, we are going to write value number equals square root, which takes float as an argument. So we're going to write, let's say, the square root of 16. And it's also important to import the square root function provided by Kotlin. And as you can see up there, it will import kotlin.math.squareroot. And we are just going to print line the square root of 16 is, and we're going to add an equal sign, interpolate the answer, and we're going to enter a number there. And if we click play, you'll see that this do something function was called in the main, and that executed all of these lines of code. So it says I did something, and the square root of 16 is 4. And also if you do value random number and you equal that to 1 to 10 and call .random at the end, that is another function that is provided by Kotlin, which randomizes the numbers. But the next kind of function I want to show you is a function that can take arguments and can return values. But first let's create one that says add numbers. And it's going to take first a number 1 of type int, and then a number 2 also of type int. And these are called parameters. And we're going to write a few lines of code inside here that adds these 2 numbers together. So we're going to write value total equals number 1 plus number 2. And we want to print the total. So we're going to do total equals total. And then of course we need to call this in main. So we're going to write add numbers. And when you enter numbers here, they turn into arguments, which means 12 is an argument and 24 is another argument. I forgot to add a parentheses here. And it will successfully calculate the total of 12 and 24. And it is also possible to provide default values as parameters. So if we go here and we also, let's pretend we want to add a string. So we're going to write message of type string, and we're going to just add a default value of this is a default string. You can do this and it will not give you error if you decide not to add the string there. And right under we will just print line the message. So we'll write message there. We will expand this a bit so you can see what's going on. And as you can see there, we have no errors, even though we have 3 different parameters and only inserted 2 arguments. But in case we want to add a message, we just write here's a message. And it will override this and it will print this message instead. So if we click on play, you'll see that it will output the total of 36, which is the sum of 12 and 24. And it will also write here's a message, which is what we specified as a string over here. But let's just get rid of the message and click play again. You will see that it's printed the default string that I entered earlier, the one over here. And that works for numbers, floats, or any data type that you insert as a parameter. And finally, there's one more thing I want to show you regarding functions, and that is how to return a value in case you want to use this function as an expression instead of as a statement. We can just write return n1 plus n2. And of course, we need to add the return type up here. So you can do that by creating a double dot after the parentheses with all the parameters and writing the desired type you want to return. So we're just going to return an int. So this function adds n1 plus n2. It will print the total and it will also return the value of n1 plus n2. So up here we can create a value of total and equal it to add numbers. And we can just get rid of these 2 and print line the results, which is total. And just for fun, let's change this to 100 and change this to 99. And if we click on play, we should get 199 printed to the console. And those were the basic uses of functions, and they are just nice for creating reusability in your code. And yeah, that's actually all I wanted to go over in this video. If this video was of use to you, please consider leaving a like. Otherwise, I will see you in the next video. Thanks for watching. Alright, so in the last video I actually forgot to cover one very small detail regarding functions. But essentially, let's pretend you have this private function that says add numbers, and it takes these parameters, which is number 1, number 2, and a message. And they all have default values, such as 10, 20, and hello. But let's go and call it. So we're going to go add numbers. Now, if you just go 1, 10, and enter the string, you will have to do them in order. But another way to add the argument that you desire is just to write whatever the argument is named, and write message equals hello. And that will save you the trouble of having to define all of these before you get the message. And you can actually do this in any order you want. If you want to define N1, you can also do it later. And that's just a very nice tip for saving time if you just want to change the value of one of these parameters. But anyway, let's just get rid of that. And let's move straight on to recursion, which is actually going to be quite a confusing topic, but I will do my best to simplify it. And to get started, we're going to create a very simple function called recursion example. So let's get started immediately by doing that. Private function recursion example. And it's going to take an input of type int. And finally, it's going to return an int. But let's get started immediately inside here by writing a return statement. So it's going to be return if n is equal to 1. And it's very important you add one of these statements so you can actually exit the recursion, because if you have an infinite recursion, for example, you will definitely generate an error. So we'll do private function infinite recursion, and then we will print line infinite loop, and at the end of this we will call infinite recursion. So as you can see, this will create this, which will create this one more time, and it will create this, and it will go on forever, and it will never end, and it will create a lot of errors. Let's just comment this part out for now so we can run the program, and I can show you what I mean. We will type in infinite recursion, and we will click on run. And as you can see, it immediately generated an error. The first thing the program tried to do is print out this infinite loop for an infinite amount of times. But eventually you arrive to the error, which is going to say exception in thread main, and you will get this stack overflow error. And that's because we tried to loop it far too fast, far too many times. So this is usually an error you will encounter when you try to use recursion. And that's why we are including this safety mechanism that tells it to stop at a certain point. Let's just uncomment that, and let's close this and get rid of that. So let's continue with our function recursion example. So return if n is equal to 1, we want to first print line the total. So it's going to be n, and we're going to add a backslash and n to provide a new line. And then under that, we're going to write print line recursion has ended, because if we arrive to this n equals 1, that will be the final condition before we exit from this recursion. And we will return the final value of n. Else we want to print n with a plus symbol immediately after it. And this is just for presentation purposes. This will be the final symbol that is printed before we get the result. And we will return n plus recursion example. And this time we want to decrement the number by 1. So each time this loops, we decrement it by 1. It will do the calculation again. Then it will loop again. It will go back here, but with a -1. And as soon as n turns into 1, we can finally exit out of this recursion. And that would be the most simple way I can put a recursion example. But let's actually play this program so you can see what it does. And we will enter the integer 5 as an argument. And let's tap on play. And actually, before I continue, I forgot that this should be wrapped in a print line statement. So we're just going to write print line, because this is actually an expression in the end. So it's very important we print the final answer. So first of all, it's going to print all of this nonsense, and then it's going to print the final answer of what we got there. So when we click on play, you'll see it says 5 plus 4 plus 3 plus 2 plus 1, and then it will say recursion has ended. And the sum of all those numbers will be 15. So this can easily be accomplished with a for loop. But this is the most basic example I have of how to use recursion. And if we put large numbers such as 50, you'll see it will calculate all of those numbers, and it will give us the final answer down here as soon as the recursion has ended. So you got 50 plus 49 plus 48 plus 47, all the way down to 1. And you can definitely use this for other things like Fibonacci numbers, but I have not used this for anything yet. I feel for Android development, it might be quite unnecessary, but it's always good to know that you can use this for something in the future in case it just happens to be the only way to do something. But with that being said, thanks for watching this video. If it was useful to you, please consider leaving a like. Alright, so what is up guys? In this Kotlin tutorial I'm going to be going over what classes and objects are and how to use them and how they simplify programming in object-oriented programming. So let's get started immediately. Right here, as you can see, it doesn't look like much code, but we'll just jump into it. I'm going to click on play. And as you can see, it says brum, 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 brum. The engine of your BMW is now running, but the car is parked. And now we start driving at 20 kilometers an hour. And then at 80 kilometers an hour, and then we try to turn off the engine, but it tells us not to do that because we're driving. And then we park our car and it says we are attempting to turn off the engine, and we have successfully turned off that engine. Now you may be wondering, how did all of this turn into all of this? To get started, I created an object of car, which was the class over here. I'll show you right after what it is, and here it would insert the car type. So that is how we started off the program. And then using this car value, we can actually call all of the functions that we have defined inside our car class. And what do I mean by that? Now let's go to our car class. Let's just close this window over here. As you can see, we have a class called car with a car brand as a parameter, or as the constructor. And we have functions such as start engine, such as drive, and such as turn off engine. And we can call each one of those functions in our main function just by appending to it the function to the value of car that we have instantiated here, and adding the arguments that are required. So this can simplify a lot of things when it comes to having a nice code structure. But since this is a lot of code to just explain, I'm going to start this whole project from scratch. And the first thing we are going to want to do in our new project is create a new class. And to do that, we'll go to source, we will right click, and we will click on Kotlin file.class. And inside here, we're going to write car. And that's going to create a class of car. And a class is just a blueprint. That's the most common explanation you will get for a class. It's just a blueprint. It doesn't do anything. It just holds all the data and logic for what it should do. So if you were building a building, this would be the blueprint, and the bricks and all the structures would be the actual object. And the first thing we want to do here actually is add a constructor. And we will talk about constructors in a future video, but for now just copy this. So we'll do car brand, and that's going to be of type string. Then inside here, we're going to create a few variables. So the first one's going to be private var is turned on. And this is going to be applicable to the engine. And we're going to set that to false, because your car should be turned off by the time you find it, preferably. And then we're going to write var speed and initialize it with the value of 0. And finally, var brand, which is going to be the car brand we passed into the constructor. Now, the first function we want to create is going to be a function called start engine. And this is so we can actually turn on our car. And just for now, I'm going to add these two slashes and write to do. And this is a cool keyword you can use in case you don't want to put in the logic yet, but you still know what functions you are going to need and what kind of logic you are going to need for the project. Then we're going to write function drive, and that's going to take speed as a parameter of type int. And we'll write to do here as well. And finally, we'll go down and write function turn off engine. And we will write to do here. And so far, as you can see, this is the basic functionality I used to create the previous program. And this is all the car needs to know how to do for this car to function. And I'm not going to go and type in all the logic I wrote earlier, but I will just add some very basic statements so you guys can see how it works, and we can keep this tutorial short and simple. So the first thing we want to do is add a print line statement to the start engine. So we'll do print line, or whatever sound your car makes when it starts up. So I just put in random letters like that. And that is the first thing that's going to happen when you start the engine. And then down here, we're going to write thread.sleep to give this program a fake delay between statements so we can read it in a nice order and it doesn't just pop up all the information at once. So we'll do thread sleep 1 second, and we will print line your brand is now turned on. So when we print this, it will say your brand, and if you put BMW and Mercedes, it will say your Mercedes or your BMW or whatever car you decide to put in there. It will put that car there, and it will tell you that the car turned on. And then we'll write thread sleep after that as well, and give it another second delay. And that's all we're going to do for the start engine logic. Then we're going to go to drive. And of course, we need to write if is turned on. Then we can write all the logic we need because we want to make sure that the engine is turned on when we drive the car, or else it is a very efficient car that works on magic. And just to simplify this, I'm going to write only one statement in here, and that's going to be if speed is more than 0, we will print line car is driving. And then we're going to add an else statement here, and it's going to just tell you that if we are not moving, the car will be parked. So car is parked. And then we should add another else statement out here for the if the engine is turned on. And if it is not turned on, it's going to print line cannot drive car with the engine turned off. And that's a very simple drive function. And finally, in our turn off engine function, we're going to write if is turned on. Then we're going to write should equal false. And we will print line engine turned off successfully. And we need to add that parentheses at the end. Else we will write your engine is already turned off. And those are the basic functions we are going to need for this very basic app. So let's go back to our main function. And the first thing we have to do here to be able to use this class that we just created is instantiate it, so we can use it in this project. So the first thing we're going to do here is create a value of car, and that's going to equal car. And we have to add a car brand to the constructor, so we're just going to do BMW again. And then down here we can finally call those functions that we had in the class. And this saves us time and is just very efficient for bigger projects. So we can do car.startEngine, then we'll do car.drive at the speed of 10, and then we'll do car.drive and put it at 0. And finally, we will do car.turnoffEngine. And if we play this program, we'll make our funny noise. It will start the car, and it will tell us we cannot drive the car with the engine turned off. That is because we forgot a very crucial point in the start engine, and that is to set is turned on to true. And now if we go back to main and we click on play, you'll see your car is now turned on, car is driving, car is parked, and finally your engine is turned off successfully. So using classes and objects definitely helps you clean up your project by a lot and can be very efficient. And this was the very basic concept behind how you can use objects and classes. And in the next video, I'm going to be going over constructors and how to use them with classes. Just keep in mind that this was a constructor, and I will go much further into detail on how to add more constructors, initializers, and just why they are nice to use in many situations. But for this video, that's all I wanted to cover. Thanks for watching, and I will see you guys later. So in the last video, we talked about classes and objects. And in this video, I want to go over what constructors and init blocks are. And let's just jump right into it. It's much easier if I just show you an example. So the first thing we are going to do is go to our source file and create a new Kotlin class. And that's going to just be class, and we're going to call it coffee machine. And to create a constructor, all you have to do is create a pair of parentheses at the end of the class name. And inside here, you add what values you require for this class to work. So we will start with the coffee in machine, and that's going to be a Boolean. And then we will also write the kind of coffee. So we'll just write coffee, and that's going to be of type string. So adding this underscore right before the name is one of the conventions you can use for constructors, but there are many, so you can just pick whichever one suits you best. But I'm just going to use this one for now. And right below, we can actually create these values. So we're going to write var coffee in machine, and that's going to equal the coffee in machine from above. And we're going to do the same thing for the kind of coffee. So var coffee is going to equal coffee. And then we're going to create a very simple function that will tell us what kind of coffee is in the machine if there is coffee in the machine. So we will write function coffee function, just to keep things simple. It's much better if you have a more descriptive name, but for this example, this should suffice. So inside here, we will create an if statement, which will say if coffee in machine, print line, you have coffee in your coffee machine. Else we'll write print line, your coffee machine needs coffee to work correctly. And with that being said, we can go back to our main activity, and we can instantiate this coffee machine by typing value coffee machine equals coffee machine. And this time it's going to ask us to add a few values. The first one being, is the coffee in the machine? We can write, let's just write true to keep things simple. and then it's going to tell you what kind of coffee. So we're going to write Kenya, coffee from Kenya. And then if we click on play, of course I messed up because we have to call the function. We'll write coffee machine.coffee function, and then we can click play again. And it will say you have Kenya beans in your coffee machine. That is because we do have coffee inside, and it is of type Kenya. And if we change this to false, it will say our coffee machine needs coffee to work correctly. And that is the very basic use of the constructor. You can just add values that need to be initialized as you create the object. And I also want to show you what an init block is and how to use it, because it is also very, very nice to have. And let's pretend you have more logic that you want to enter, and that doesn't really fit into your constructor. Well, with the init block or the initializer block, we can actually add a lot of logic that we cannot add in the constructor. And that can simplify a lot for us. So let me give you an example of how we can use that. To create an initializer block, all you have to do is type in the keyword init, and inside here, this will act as a secondary constructor. So immediately after this has been called, we will have this right here that will be called before any other function inside the class. So actually we can just copy and paste this here. That means once this object has been created, this will be printed immediately without even having to call the function. And let me show you what I mean by that. Let's delete that function. And inside here, we can actually delete that part as well. So with the init block, we have added this check that if the coffee is in the coffee machine, you'll say you have this coffee in the coffee machine. Otherwise, your coffee machine needs coffee to work correctly. So now if we click on play, it says your coffee machine needs coffee to work correctly. And it's never used, but everything is initialized and everything is processed. So this gets called before any of the functions, and so does this, and this can act as a secondary constructor, although Kotlin does have secondary constructors, and I won't go into that because they are seldomly used. But for now, I would say the most important aspects are this constructor part right here and the init block that you can use at any time you want, and you can even have several. And you can insert something as simple as checking whether A is bigger than B and then printing out the value down here. So to sum it up, initializer blocks are just nice to have for the logic that you cannot fit into your primary constructor. And you can add a lot of code in here, whatever you want to start off your object. And there's actually one more thing I want to show you that I actually forgot in the previous video, and this is regarding classes and objects. So we're just going to add a print line statement or a function that says print. So we're going to do function print message. And inside here, we're just going to type print line, and we are going to interpolate. We're going to write coffee and add the coffee down here. Then we can go to our main activity. And what I didn't show you in the past video is that you can actually change the values from outside the coffee machine class just by appending its name to the original value. So coffee machine.coffee, and we can equal that to Honduras. And then down here, we will write coffee machine.print message. And just to show you that that changes the value from within the class, we will do it under. So we'll write changed value, and we can click on play. So as you can see here, it says coffee Honduras and then coffee equals changed value. So it's really nice that you can change the value from outside the class just by appending to it the value that you want to change. And just make sure that it is a global variable, because if you have the private keyword, it will not let you access that variable. So it is very important you have that as a normal variable. But I believe I covered everything you need to know for the basic usage of initializer blocks and constructors. In the next video, I want to discuss getters and setters in Kotlin. But as always, thanks for watching, and I will see you guys later. So in the last video, we talked about constructors and initializer blocks. And in this video, I want to go over how to create getters and setters. And these are actually more popular in Java, because in Kotlin, it automatically generates them for you when you try to access a property value. But we're just going to jump right into it by creating a new class. And this is going to be a class called person. And inside person, we will create a variable of name, and it's going to be of type string, which we can assign to default value in case nothing is given. And usually the way you would create a getter or setter is immediately under the variable name you want to get and set the name for, you would type in the keyword get followed by fields. And this would be enough to retrieve this field when you are accessing it. And to set a value for this field, you would just call set, and you would type in value, and inside here you would write field equals value. Now in Kotlin, all of this is not necessary, so it is just essentially extra boilerplate code if you do decide to write it. But for now, I'm just going to go to our main function and instantiate our person. So we're going to do value person equals person. And then to change the name of the person, we will go ahead and type person dot name, and we can equal that to Tom. And then right under, we will write println person dot name. So right here we are setting the value, and right here we are getting the value. And when we go ahead and click on run, you will see that it outputs the name Tom. But now that we covered the basic usage of the getters and setters, we're going to move ahead onto a more complicated example, and let's just get rid of everything we've written here. So the first thing we're going to do down here is create a class named guy, and inside here we will create a variable called age, and it will be of type int, and we will assign to it the value of 0. The first thing we're going to add down here is a getter, so we're going to write get. We can actually expand that by adding a pair of curly brackets, and inside here we are going to write println age has been accessed, and we want to return the field because it is required. And then for the setter, we're going to write set, and as usual, value, and we are going to add some curly brackets as well. And inside here, we will write field is equal to when value is less than 18, we are going to assign it 18. When the value is in the range of 18 to 30, we will assign the value of value to it. Else, we are going to return the value -3. And we are also going to add a println statement to show where we have used the setter. So we will write angle brackets and age has been set. And at the bottom we want to write the actual age. So we write actual age equals 0. And after we have created this very basic class, we can go ahead to our main function. And the first thing we're going to do is instantiate guy a couple of times. So we'll go value James is a guy. So we will instantiate that, and we'll do James.actualAge is going to be 15, and then we'll write James age is also 15, and then we will println a couple of statements, which actually I will copy and paste from the previous example. So we'll have a println that says James actual age, which takes the James actual age value and inserts it here, and then we'll have a println statement that says James pretended age, which will take the James age, and it will put the value in here. So what's happening here is this is the actual age, which will just return itself. But once we set the age here, it will go through this field here and it will return the value based on which value we input. So if we input a value under than 18, it's going to return the value of 18. If we put a value between 18 and 30, it will return whatever value we've inserted. Otherwise, if the value is anything that's none of these two, it will put that value in and it will subtract 3 from it. So we can actually go ahead and click on play. And you'll see the first thing that happens is it will say that the age has been set because we have accessed the setter property here and we have set the age. Then it will say the actual age, which is the next println statement down here. And then it will say the age has been accessed. That's because we have inserted it here and it had to get the age in order to use it. So it first will print this statement, and then it will print the whole println statement. And we can actually create one more random figure. So we'll go in here and we'll write Peter, and then we will change all of these to Peter as well, with the only difference being the age. So we will write 35 here and 35 here. And it's very good if we create a divider. So we'll do println, use our favorite escape n, and then add 3 hyphens. But let's click on play. So here you will see that we have instantiated Peter as another guy. Actually I forgot to change these. So we instantiated Peter as another guy, and Peter's actual age is 35, and Peter's age that we set it to will be also 35. So the first thing that's going to happen, it's going to state that we have set the age of Peter because we use the setter to set the age, and it will also print this println statement because it's part of the setter. So age has been set, Peter's actual age is 35, and then we will try to use that age over here. So it will say age has been accessed because we are using the getter to get that age, and because it is more than 30, it will subtract 3 from it and it will say Peter's pretended age is 32. And those were the basics of using getters and setters in Kotlin. In most case scenarios, you will never have to use them because if you just create var age and you try to change it, Kotlin will generate all the getters and setters for you, so you can just change the age comfortably. And actually that was a bad example because I didn't change the values, but if we change this to 40 and we change this to 50, you'll see that it will print the actual age of 35 and Peter's pretended age of 50, because this calls both the setter and the getter under the hood. So that's another nice thing in Kotlin. It reduces a lot of boilerplate code when it comes to getters and setters. But that's all I wanted to go over in this getter and setter video. In the next video, we'll be going over inheritance and how that works in Kotlin. But for now, I will see you guys in the next video. Alright, so what is up, guys? In this video, I want to go over what inheritance is and how you can use it in Kotlin. So let's get started immediately by creating a sample project. And the first thing we are going to do up here is create an open class, and it's going to be named person, and it's going to take two parameters in the constructor, which are going to be age of type int and name of type string. Then we are going to create a block, and inside this block we are going to create a value at the top called apple price, and that's going to equal 10. Then we are going to create an init block, and inside here we will write print line my name is name, and then we will just create another print line statement right below it, and that will be my age is age. And right below that we are going to create another open function. This one's going to be called open function walk, and inside here we will write a print line statement that says walking is good for your health. So right below we are going to create a new class, and this is going to be a class called coding teacher, and it's going to take age of type int and name of type string in its constructor, and we are going to extend person because the coding teacher is a person, so we can extend this class and use all of its properties inside the coding teacher class. And of course we need to pass into the constructor the age and the name. So we're just going to write age and name here, and this will be derived from these two over here. So that's very simple. And inside here we will create a function called teach maths. Then we will add a few print line statements. The first one's going to be I am a coding teacher and I teach code with an exclamation mark. And right below we can write print line the price of an apple is, we'll add this pound symbol, and we will add the dollar symbol to interpolate, and we will write a pair of parentheses inside, and then we can write apple price, and we're going to multiply that by 0.10, and we want to convert that or cast that into an int. So as you can see, we created this new class which inherits from person, and inside this class we have no such value of apple price. So the way we got this apple price is by inheriting it from the person class, so we can use this value apple price inside here. But anyway, we're going to go ahead and create another class. This one's going to be called class businessman, and it's going to take the same constructor and the same inheritance from person, so we can just copy and paste that and put it right here. Let's get rid of these two parentheses, and let's create a block. So the first function inside here is going to be function do business, and we're going to create a few print line statements. The first one is going to be print line I am a businessman and I love to do business with an exclamation mark. Then we'll create another print line right below, but for this one we're just going to take from our previous statement in the coding teacher and paste it right in here. So we'll add another pair of quotation marks, and we will interpolate the apple price again. We'll write apple price, and that will take care of the function we created in businessman. And finally, I want to show you that you can actually also access these functions from the other class just by typing in walk. It will give you this option to override walk. And what overriding does is call the previous function. So the super walk is this function precisely. And if you want to override it and add your own code, you can either get rid of this and completely start from scratch, or you can leave it there and it will call printline and add whatever you want to it. So we can write printline, and inside here, I added code to this walk function. Perfect. So just to explain what we did here once more, we created an open class called person, which takes age and name as parameters. And we're going to use this class to pretty much create a base for all the people we will create. So coding teacher is a person and businessman is a person. So we're going to use this class and inherit from it because all people have basic functions. And to keep it simple, we used a person class which defines these basic functions, so we could save time and not have to rewrite all of these functions each time we create a new class. For example, we don't want to create my name is name and my age is age each time we create a new human. We just want that to be part of the person. And all the people can walk, so we will always have this walk function available for all the people. We can also override that in the coding teacher class. but it's not necessary for this example. And it's just good to have a standard place to inherit from, so you can follow some code structure. But if you were to create a class named lamp, maybe this would not be the most appropriate or fitting solution for the class of lamp. Because unless your lamp has a name and an age and can walk, none of this code is really applicable to the lamp. But let's continue with this example, because all we've done here is create a few classes and we have not tried to use any of them yet. So right down here in our main function, the first thing we are going to do is create a value of teacher and instantiate our coding teacher. So we'll get coding teacher, and inside here we will pass the arguments that it requires, such as age. We'll give it 37, and we will name our coding teacher even. And the first thing we want our teacher to do is to teach math. So we'll write teacher.teachmaths, and that will call that function. And right below that, I'm going to create a quick break, a line break, just by adding an escape and adding 3 hyphens. And then below that, we are going to create a businessman. So we're going to write value business equals businessman, and his age is going to be 28, and we are going to name him Max. Then we're going to write business.doBusiness to call that function that we have created right here. And then we can also try to call the overridden function. And the way we do this is just by typing in business.walk, and everything will be taken care of. Now, the final thing to do here is actually to go ahead and click on play. So we will do that. And as you can see here from the main class, the class that was inherited from, we have the initializer block, which called my name is Even and my age is 37. It says I am a coding teacher and I teach code, and the price of an apple is £1. So the one was inherited from our open class of person, and so were these 2 print line statements from the init block, which also were inherited from person. And then we also have the second person we created, the one down here, the businessman, and his name is Max. He is 28 years old. I am a businessman and I love to do business. The price of an apple is 10. We forgot to use the pound symbol. Okay, there we go. So the price of an apple is £10. Walking is good for your health, and I added code to this walk function. We can also choose to not add any code to the overridden function of walk. We can just go teacher.walk, and that will inherit it from the person class. So when we click on play, it will just write whatever code was originally in walk. Walking is good for your health. So the teacher agrees, Even agrees, Max agrees, and those are the basics of inheritance. But that will be all for this video. Thanks for watching as always, and in the next video we will be going over visibility modifiers. But anyways, I will see you guys in the next video. Ciao! Alright, so what is up guys? In this video I want to go over what visibility modifiers are in Kotlin, and let's just get started immediately by creating a sample project, because I've tried to record this far too many times without getting anywhere. So the first thing we are going to do is create a new class, and we're going to write Kotlin class, and here we will type in fruit. And the first thing we're going to do in here is change this to an open class and add a constructor to this fruit. So we're going to add this fruit, and it's going to be of type string. And then immediately under we are going to write an init block, and inside here we will add a print line statement which says you chose a fruit. And it will add the fruit that we've added to the constructor. And then down here we are going to write open function say hello, and we will add a print line statement of our class saying hello. So we'll write fruit says hello. All right, and for this function you may have noticed we have the open keyword, and this allows us to use it and inherit from it. And another thing to bring up is if you're coming from Java, you may be familiar with the concept of adding the public keyword everywhere to make sure that a function or a class is public. But in Kotlin, if you do not specify that it is private, it will automatically be considered public. So you never really have to add the public keyword anywhere, because all classes and functions that are not specified as private become public. So as you can see here, we have an open public function that says hello. And right below that, we are going to write one that's called private function, and that's going to be hello private. And we will add a print line statement, and this one will say I say hello privately. Now, as you can see, we have defined this as private, which means we will not be allowed to use this anywhere else besides in this class. It is linked to this class and you cannot inherit from it. And then after that, we have the protected visibility modifier. So if we write protected open function say hello protected, and then inside here we write I say hello while I am protected. And essentially the protected keyword is exactly the same as the private keyword, with the exception that protected is allowed to be inherited from. So you can use it in other classes that inherit it from fruits, as opposed to this private function here, which is only allowed to be used in the fruits class. And it is also possible to use this protected keyword for values. So we can write protected open value caret, and we're going to assign that the string of caret. But anyways, that's all we're going to do for our fruit class. Now we are going to create a class that can inherit from it, a subclass, if you will. So we will call it class subclass. And that will take a fruit as a string, and it will inherit from our fruit class, which requires the fruits in the constructor. And the first thing we are going to do is demonstrate that we can actually use this caret value anywhere in our subclass. We will write value item equals caret. And one more thing, you only need this open keyword if you want to override the value of caret. So for example, if you want to override it, you just type in caret and it will say override value caret, and it will create a getter for you. But without that open keyword, you will not be able to override this value. And yeah, that's just a small thing to note when developing in Kotlin, but we will continue without that open keyword because we do not need to override caret. Instead, we are going to override the function say hello protected. And to do that, all we have to do is write say hello protected, and it will let us override it. So instead of writing I say hello while I'm protected, you can also just write print line and say this say hello protected function has been overridden. And that will completely replace what we wrote here with what we put here. So if we just left it with the super keyword, it will call whatever we put in here and everything will stay the same. So if you want to keep what you have in here and add some extra text, you can definitely just add it below. And yeah, that's all. So add extra stuff. And then the next thing to show you is that you can still use the say hello function because it is open and it is public. So if we just write override function say hello, it will let you do that. And we will just leave it to super.sayhello so we don't have to write anything inside there. And the final thing to show you is that we cannot really access the hello private function. So if we just type in hello private, it will not allow us to do that. But anyway, let's go back to our main function. And inside here, we are going to create and substantiate an object of fruit. So we'll write value fruit equals fruit, and we are going to write apple. Now we're going to write fruit.sayHello. And this sayHello function is the one that we found over here. So you will see that we cannot access the other two because first of all, one is private and the other one is protected. So if we write again fruit.sayHello, you'll see that there's no sayHello privately and there's no sayHello protected. These functions are completely unavailable when it comes to accessing them outside of the fruit class. But now let's create our subclass. Let's write value subclass, and that's going to equal subclass. And of course we need to pass in a fruit, so we'll write orange. And let's just type in subclass to see what we can do. And you will see here we only have access to the item and to say hello. That is because we created an item which has not been specified as protected or private, which means we can use it as public. And that just takes the value from caret, which is protected. So we cannot use that one, but we will use item. Then we have an overridden function which says hello protected. And since this function is protected, we cannot use it anywhere else besides inside this class and this subclass right here. So if you wanted to use this, you would have to write open function say hello protected. And now if we go back here, we can write say hello protected and it will allow us to use that. Anyway, let's click on play and see what we get. So the first thing that happens is we chose an apple in our fruit class and we print lined that you chose an apple, and then it says fruit says hello because the thing we did immediately after that is say hello. Then we created a subclass which says you chose an orange. That is because we inherited from our fruit class, so we use the same initializer. And then it says I say hello while I'm protected, which is a false statement because we removed the protected visibility modifier. And finally it says add extra stuff because we decided to override the function of say hello protected, which means we added this extra print line statement. And there's actually one more visibility modifier that I should go over, and this one is called internal, and we will just use it in the example of orange, and we're going to create a string named orange. And the reason I was quite reluctant to bring up the internal visibility modifier is because it is used only in modules, and it depends if you have a multi-module project whether you should use this or not, because essentially with this internal value we can use it in all our classes as long as it's in the same module. And modules are a completely different discussion, but it's good to know in case you are very familiar with modules that this can prevent this value of orange from being leaked out to other modules. But I can't really go too deep into that because I myself am not really familiar with modules, and that is 100% up to you. I have never used this keyword in Android Studio, but I'm sure that someday there will be a moment that I might go ahead and use the keyword internal. But anyways, I hope that wasn't too confusing and you got a general idea of how to use visibility modifiers. Thanks for watching as always. I will see you guys in the next video. Ciao. Alright, so what is up guys? In this video I want to go over abstract classes and how to use them in Kotlin. So let's get started immediately by creating an abstract class. So we're going to write abstract class, and this is going to be a person. And inside here we are going to create a block, and we're going to create a variable of age, which we are going to assign the value 27 to it. And then we're going to create a function called display age, and it's going to take age as a parameter. And inside here we will write print line age is age. Then immediately under we are going to write an abstract function, and we will just start by writing abstract function print message, and that's going to take a message of type string. And then below this we are going to create another class. This one's going to be a normal class. It's going to be called class coda, and that's going to take a name in the constructor of type string, and it's going to inherit from person. And you might already have noticed that the class coda has a red underline there, which means it wants us to do something, and that is because we are using an abstract class. And the difference between an abstract class and a normal class is that you cannot instantiate an abstract class. You can inherit from it, but you cannot instantiate it. So we need to click on implement members, and it will override this abstract function of print message. So you can think of abstract, the abstract keyword, as kind of like a contract. So everything in the class that extends person must use this abstract function over here, because that is the contract they have agreed to. And actually we are going to create another value. So we're going to write private value name equals underscore name. Then inside the print message function, we are going to write a print line statement. And inside we will write your name is name. Another print line statement, which will say personalized message, colon, and we are going to enter in our message. And one more thing I forgot to mention is that this abstract keyword means that the class is open, and it will always be open as long as it is defined as an abstract class. So these are both open. This is an open function and this is an open class. And that's why we can use it so easily down here. So we can also write abstract var. And as soon as we turn this into an abstract variable, we must implement it in our coda class because it is a contract and we must implement it. So we will click on OK, and you'll see here that we will override the variable of age in our constructor, and everything will work fine. But let's get rid of that and let's move straight to our main function. We can try to create a value of person and use our person class, but the IDE will not be happy with that because it will tell you that you cannot create an instance of an abstract class, and that is because it is an abstract class. So instead what we are going to do is write value coda, and we are going to equal that to coda, which inherits from the abstract class and gives it all the methods it needs. So we'll write a name, which will be even, and let's just add an R there before I forget. And then down here we'll write coda.age, and we will assign that to 54. And then we will write coda.displayAge, which is the function from the abstract class. So we do not have to create it inside the coda class because it has been inherited from person, and we can just use it anywhere we want. So inside here we will write displayAge, and we will take the coda.age, which has been set to 54. And finally we will call coda.printMessage. And the message we will include for this one is I love to code. And as you can see, abstract classes are actually very easy to use. So in the end, let's go ahead and click on play. And you can see as soon as it's done compiling that we get the age is 54 because we set it here. Then it says your name is even, and that's because we entered the name of even here, and that placed it right in here. Then we have a personalized message that says I love to code, and that is the message that we chose to include here, which also got included in our print message function. But anyways, I hope this video helped to clarify what the abstract keyword was used for and how it could be used to simplify creating subclasses or classes that want to inherit from other classes. It just simplifies quite a lot. But that is all for this video, and I will see you in the next one. Ciao. Alright, so what is up, guys? In this video I'm going to be going over what interfaces are in Kotlin. And let's just get started immediately by creating a few of them and seeing what they do. So the first thing we will do is go to our source file and right click on it and click on new Kotlin file.class. And this time we are going to go ahead and click on the interface. So let's give this interface a name and let's call it Apple. So an interface is going to be a lot like an abstract class in which we create kind of the structure of what a program should do, the contract of what the program should do, and then we can use this and implement it in different classes. So let's just get started immediately by typing a very basic function, and inside this interface we will call this function fruit, and inside we will write print line I am a fruit. And then let's go ahead and create another function. So let's go new Kotlin file class interface, and we're going to call this one banana. And banana is going to have a value of sugar, and that's going to be of type int. Then we're going to create the same function that we had in Apple, so function fruit. So let's control copy that and paste it right in here. And let's also create a function that has no body but returns a certain data type. So we'll write function write something, and that's going to return a string. And finally we're going to create another random function, function hello, and inside here we will write print line hello mate with an exclamation mark. So that's all we have to do with our interfaces so far. We created kind of a structure for our program, and once we implement this interface we will have to follow what it has or the program will not allow you to continue. So another simple example would be having a lamp. You really want to make sure that it has a switch and that the power is on. So you can add all of those functions and values in the interface. That just makes it easy for the coder to know that he must use these functions, and that is how the lamp works. But let's continue with the Apple and Banana interface. So let's go back to our main Kotlin file, and inside here we are going to do a few things. And the first one is create a class. So we're going to write class fruit, and that's going to inherit from the banana interface. And you may have noticed that as soon as we have decided to inherit from the banana interface, you will get this red error on the class fruit. And if you just alt enter on this class fruit, you'll see it gives us a few warning messages and solutions. And the main reason being it requires us to implement the functions that are inside the interface. The program will not work unless we implement these functions. So the banana had write something and sugar.int that must be implemented. So if we click on OK, you'll see that we will have a overridden getter method for the sugar, so we can assign it a value. And we'll have an overridden function for the write something. And you may have noticed that it did not require us to override the fruit function and the hello function. That is because we already have some code inside it, which tells the program, okay, we already handled this part, but you can definitely override it if you want. So if you go in here and you type in override function fruit, it will call super.fruit. And you can write whatever you want in there, like print line, I am a crazy fruit. For sugar, we will write 10. Maybe 10 grams of sugar, who knows. And for the write something function, we are just going to remove this block and we're going to add the equal sign, and we're just going to write I am writing something. So all of these functions have been used besides the hello one, which we can also use over here, and it will just call super.hello. But we have created the structure for the fruit. It tells you how much sugar there is, it writes something, it says that I'm a crazy fruit, and it also says hello. Pretend these are the basic functions of the fruit. And using this interface just made sure that we would do what we had to do with the banana. So if we go back to function main, we can definitely instantiate this by doing value fruit equals fruits. And then right below, we can definitely call all of these methods that we have overridden. So we can do write something, and then we can also go fruit.hello. We can also write print line fruit.sugar. And I absolutely forgot that our write something function is actually an expression that returns a string. So to make this work, we will just surround this by parentheses and write print line fruit write something, because that will return us this string. And finally, we also want to write the fruit.fruit function. And then we can just go ahead and click on play to see what we have done. But anyway, here you'll be able to see that the first function that we wrote is I am writing something, because we print lined this statement over here. And then we have the hello function that was called by the fruit. It says hello mate. The sugar of the banana is 10 because we decided to write fruit.sugar. in that printline statement. And finally, we have the fruit.fruit function that says, I am a crazy fruit. So we implemented everything we had to from the interface, and that just simplified life by a lot. Now there's one more example I want to go over before I finish this video, and just imagine you had multiple interfaces. So to add multiple interfaces, all you have to do is add a comma and write the other interface you would like to add. So this class fruit is going to use banana and apple. Now, usually this would be very easy and fine to do because it will just give you an error and it will tell you which you need to override. But there's another problem. Right now we have a function called fruit in apple and a function called fruit in banana. So exactly which one is being overridden? At the moment it will override both of them, and we don't really want that. We want each of them to be specific. So let's just get rid of this fruit over here and we will get the error. It will say implement members, and we can implement it for banana and for apple. Let's click on OK. You'll see that we have two functions that are named exactly the same, and it will give us an error for that, conflicting overloads. So what we have to do here is actually delete one of them. So to know which interface we are going to override, all we have to do is add the super keyword and just write some angle brackets and type in the interface inside there. And with that, we can call the function fruit. So you'll have superapple.fruit, and that means we are calling the function that came from the Apple interface. And you can do the exact same thing with the banana, just by adding the term banana in here. So when we play this program, it will print both of their functions separately, such as, let's change this to, I am a banana fruit, and I am an apple fruit. Then we can just delete all of these statements and click on play. So with these super functions, we were allowed to take the original functions and call both of them separately, regardless of sharing the same function. And if you want to make sure that you call different functions, you can definitely just go in here and write function fruit banana. And inside here, you can just take the super banana and insert it inside there. And you can just remove this part here. So calling fruit will only call the apple fruit, while calling fruit banana will call the original super banana fruit. And this is one way to separate the functions from both of the interfaces. So let's just go ahead and call fruit.fruit banana. And you will see that we have successfully solved the issue of having conflicting function names. And that's all I wanted to go over in this video. I just wanted to show you that you can use interfaces to keep a clean project structure. And it just simplifies life by making sure everything that has to be implemented gets implemented. And yeah, thanks for watching. I will see you guys in the next Kotlin video. Alright, so what is up guys? In the last video we talked about interfaces, and in this video I want to go over nested and inner classes and how they work in Kotlin. And let's just jump right into it as always. So let's get started by creating a class, and we are going to call this class outer class 1, and then we are going to create a block, and inside this block we're going to create two values. One's going to be value apple, and it's going to equal apple, and then we're going to create a value called number, and we're going to assign the value of 25 to it. Then right inside we can create a nested class just by typing class, and we're going to call it nested. And this essentially means that we created a class within another class, and that's how it becomes a nested class. And inside here we can create some more functions. So we can go function print message, and it's going to take a message of type string as a parameter. And finally we can write print line and insert the message. And there are a few things you need to note about this nested class. The first thing being that you cannot access the values and the members outside of this nested class. So this class nested does not inherit from anything, and it cannot use any of these. But you can still use the nested class when you instantiate your outer class. And the way we do this is by creating a value of outer class 1. And we're going to instantiate it by calling outer class 1. And we will add the nested class at the end of our outer class. So what we're really doing is calling this class over here, which means that now when we use outer class 1, we can actually call the print message function and say, hello, mate. And that will call the function inside the nested class. But let's just go ahead and click on play to show you what we have so far. So as you can see, the program printed hello mate. So those were the basics behind creating a nested class. Now let's move on to inner classes. All right, so for our second example, we're going to type in class, and we're going to call it outer class 2. And we're going to create another block. And inside here, we're going to copy these values and paste them right inside our outer class 2. And then instead of creating a normal class, as we did here, the class nested, we are going to create an inner class. And to do this, we just have to add the prefix inner and then type class nested, just as we did above. And then inside here, we can write function print message. And this is not going to take any parameters. So we're just going to write print line. And finally, we can access the values from outside. So we can write apple is number. And as you can see, we can access everything from the outer class inside the nested class. And that's pretty great. Anyway, so let's go back to the top and create a new object. So we're going to create value outer class 2. And that is going to equal outer class 2, this time with the parentheses. And then we're going to call nested. And with this, we will have access to the inner class. So when we type in outer class 2 dot print message, it will print this message down there. So if we click on play, you will see that it says hello mate from the first class, which has the nested class inside. And it will say apple is 25 from the inner class, which accessed these values and printed it in a print line statement inside the inner class. And those were the basics regarding inner classes and nested classes. In the next video, we'll be covering how to create sealed classes and what those are. But anyways, thanks for watching, and I will see you guys in the next Kotlin video. Alright, so what is up, guys? In this video, I want to go over what sealed classes are and how you can use them in Kotlin. And essentially, sealed classes are used when a value can have only one of the types from a limited set. And this is often referred to as restricted hierarchies. So this usually means that when you have a menu and you know that menu has a certain amount of options, whether that be a list of colors or the list of volume states such as low, medium, and high volume, you can use the sealed class to list those items and react to them appropriately. But anyways, we're going to jump right into the project by creating a sealed class. And this one's going to be called volume. And we're going to create a block. And inside here, we are going to create a class called low because we are going to create a speaker which can react to our volume changes. And it's going to extend volume. And then we can just copy and paste this 3 times because we want medium volume, high volume, and low volume, of course. And then that's all we have to do for the sealed class. As you can see, it holds 3 states of being for our speakers, and that's all it has to do at the moment. Then we're going to create a function, which is going to be called function eval, which stands for evaluation. And it's going to take volume of type volume as an argument. And that's going to equal a when statement, which will take volume inside that. And we will create a block right after that. And inside here, it's going to tell us that we need to add the options that we gave in the sealed class, which means if we go to more actions, you'll see it says add remaining branches. And this will list all the possible options that we described in the sealed class. And this is a very great thing. It means that also if we decide to add a new volume, such as class super high, which extends volume, this down here will give us an error that tells us either to add an else branch or to add the remaining branches. So it will give us a compilation error immediately, and that will save us a lot of time. But anyway, let's remove that over there and let's continue with this block over here. So when the volume is low, we want to print a statement that says volume set to low. And then we will copy and paste this 2 times. So we'll set this to medium, of course, and this will be set to high. And so far, so good. Now we need to go right above our function and we need to create a global variable, which will be a late init var of volume, which will be of type volume. And then right inside function main, I'm going to add this print line statement, and I don't want to write it because it's a lot to write, but what I did here is add a new line, which is turn the volume level to new line, high, medium, or low. And then right immediately after that, we're going to create a function that says change volume. So this is going to create the question. And in here, we will have a read line statement that will receive the user inputs and it will output the corresponding volume that the user has specified. So to do that, we will create a private function change volume. And of course, we need to get the volume level. So we're going to do value volume level, and that's going to equal read line. Then inside here, we're going to write volume is going to be equal to when volume level, which is not null, contains low. And also we're going to set the ignore case to true. So whether the user decides to write it in camel case or all in capital letters or any way they want, it will always recognize that in the sentence, as long as it contains low, it will pick the low option. And then we're going to add an arrow and create another block. And inside this block, we're just going to type in volume.low. So it will select this option. And when this option is selected, it will set the volume to low. And then we will copy this one more time and paste it right under. And it does not require that this is non-null, so we can just remove that. And we will set this to medium. And we need to set this to medium as well. Then we can add our else block, which will say else the volume is just going to be set to high because it's none of the previous two. Then below this when expression, we can actually evaluate what we selected. So we can write evaluate volume. And under that, I'm going to copy and paste in another print line statement because it's a lot to write. And what this print line says is to adjust it, you need to type high, medium, or low. And that is because once we received the input from the user the first time, maybe the user thinks the music's too loud after a bit and they want to change it down to low or medium. They can still do that whenever they feel like it. So we're going to create a kind of recursion. So we'll just add the function change volume right under, and this project will loop forever. So the user can always change the volume. Of course, ideally you would want to add an off switch, but who cares? This person has the best speaker in the world and it will play forever. But anyway, when we run the program, you'll see it will ask us for some inputs, and let's just do that right now. So it says turn the volume level to high, medium, or low. Let's pretend that it's on high at the moment, so we will change it to low. And it will tell us that the volume is set to low. Then it will say to adjust it, type high, medium, or low. And of course, we can continue with some high music, and then some low music again, and then some medium music. And it will continue selecting the option we want and giving us the corresponding output as a result. And there's one more thing I want to show you before I finish this video, and that is when you create these classes, you can of course add some constructors. So you can write var message, and that's going to be of type string. And we can copy and paste that on medium and on high. And of course, to use this, you would have to add it somewhere in the code below. So instead of saying print line volume set to low, we're going to write volume set to low plus, and then we need to add the dollar symbol and some curly brackets and write volume.message. And it appears that I have written message with 3 S's. So let's go ahead and fix that. But we can copy this part right here and paste it in the other two, because volume.message will always refer to the volume that we have selected, which is great. But that also means we have to fix our when expression. So in here we can write low, in here we will write medium, and in here we will write high. So if we rerun this program, we'll click on stop and rerun. Let's set the volume to low. It will say volume set to low plus low. And if you type in medium, it will say volume set to medium plus medium, because we added this statement right here. And yeah, it's really nice to have constructors inside your sealed class. So definitely experiment with them. This may not have been the most intensive video on sealed classes, but it definitely helps you get started with using them. And I hope this video helped. If there's anything else you'd like me to cover, please leave it in the comment section below and I'll do my best to respond. Otherwise, I will see you guys in the next Kotlin video. Alright, so what is up guys? In this video, I want to go over what companion objects are and what objects are when it comes to Kotlin. So let's get started immediately by creating our sample project as always. And the first thing we're going to do is go to our source file and create a new Kotlin file.class. And we are going to click on object this time. And we're going to call this object numbers and then click on enter. Now you may be wondering, what is an object? Well, an object is just a data type with a single implementation. And that actually means that this can never be instantiated because there's only one instance of it. And I'll show you what I mean in a moment. So the first thing we want to do inside here is create a value called app name, for example. And we're going to call that objects tutorial. And then we can also add a function inside here that says hello mates. And we will add the print line statement inside here that prints to the console hello mate with an exclamation mark. Great, so we've created our object. Now let's pretend we want to print the app name to the console. Usually you would have to instantiate a class and then refer to the variable, but with objects you can just type in the object name and refer to the variable directly. So if we just print line this statement, you will see that we will have the app name printed directly to the console. And this is great since we only want one instance of this app name. We don't need to recreate it many times. We just want it to exist one time throughout our entire project. And down below, we can also add another function called numbers.hellomate. And let's just tidy that up and click on play. So you will see it says objects tutorial, which is the app name. And then it will say numbers hellomate, which is the print line function that we have defined in our object of numbers. And that's a very basic way to use this object. Now we can actually move on to another example, which is how to use companion objects. So inside here, we're going to create a class, which we will call Apple. And inside here, we will immediately create a companion object by typing in companion object. And that requires us to create a block. And inside here, we will create a private var, which is called X, and we will assign the value of 0 to it. And then we'll write private constant value Y, because we will never change this value, and it is perfect the way it is. Then inside this companion object, we will type in function random number, and this will create a value of random, which will take a random number which is specified between X and Y, and it will call random. And then right below, we will type in print line random number equals random number, which equals our random number that we generated right above. Now, exactly the same way we just called hellomate without having to instantiate numbers, we can do the same thing with Apple. So we can type in Apple and it will say random number function, which is really cool because we can just skip all the nonsense and go right to the function that we do not require to be created more than once. So let's click on play. And you will see that it says random number is 20. And the nice thing about this companion object is that if we decide to create a function inside our Apple class, let's say function fruit, and we want to use the value of X or the value of Y, we can just type in X equals 20 and it will let us use it. And we can also use the functions that we defined inside the companion object. So we can just type in random number, and then up here, of course, before we can use this fruit function, we have to instantiate Apple. So we have to write value Apple equals Apple. And then down here, we can type in Apple fruit. All right, so there's actually one small change I want to do before I continue with this function, and that is changing this back to a variable and leaving that at 30. Then down here, we can type Y equals 100. And I want to change X actually to 50. So inside here, we assigned the value of 50 to X and assigned the value of 100 to Y, which means our new random number is going to be in between 50 and 100. So that's pretty cool as well, that we already have the function made and we can just call it down here. So when we call apple.fruit, we'll have a random number between 50 and 100. So as you can see there, the first one we printed was the apple.random number, which was 15. And then we got a random number again, which was in between 50 and 100. But I really hope that helped you understand a little more about objects and companion objects. And as always, if you have any questions or comments or concerns, please leave it in the comment section below. I will do my best to read it and answer it. But with that being said, I will see you guys in the next Kotlin tutorial, which should be covering Lambda expressions, and that is quite an exciting topic. Alright, so what is up guys? In this tutorial I'm going to be going over how to use Lambda expressions and what they are in Kotlin. So to keep things simple, a Lambda expression is essentially an anonymous function. And let's just get started immediately by creating an example so you can see what I mean by that. So inside here we are going to create a value called greeting, and that is going to equal a block. And inside this block we will add the print line statement, and we'll give this greeting a hello mate as always. Now to use this, all we have to do is type in greeting and add the parentheses at the end, and that will have created this function over here. So as you can see, this print line statement is the anonymous function, and we assign this function to the value of greeting. So it's just a way of using a function without actually having to create a whole function. And if we go ahead and click on run, you'll see that it has been executed just like a normal function. Now, let's move on to example number 2. So we will just add example 1 here. Then we can go down to example 2. And in here we will type in value sum. And that's going to equal a lambda expressions. But this time we are going to include a few parameters. So we are going to write a, which is going to be of type int. And we are also going to write b, which is also going to be of type int. And we are going to use those parameters for this expression, and it's going to be a plus b. So what we did here is create a function that takes these two parameters and it outputs the sum of those two. And then if we write value result, and the result will be the sum of 5 and 10, then we can just print line the result. And when we click on play, you will see that it has returned the answer of 15. So that's another cool thing you can do with Lambda expressions is, of course, take parameters and use them in an expression. But let's continue with one final example. So the first thing we are going to do is create a data class at the top named cats. And it's going to take a value of name, which is going to be of type string, and a value of age, which is going to be of type int. Then right below we are going to create a list, so we're going to write value cats equals list of, and I'm just going to copy and paste in my previous list because it's a lot to write. So inside the parentheses we want to create a list of cats with names and the age. So the first cat is Tom with an age of 5, then we got Patrick with an age of 10, and so on. Now let's pretend we want to find the oldest cat in the list. Well, we can use a lambda expression for this. So let's get started by creating a value of oldest cat. That's going to equal cats dot max by, and then it will provide us this block which requires us to insert a lambda expression. So what we will do is type in cats, and right after we will type in cats dot age. And then of course we need to add the print line statement. So inside here we will write oldest cat is the oldest cat. And when we click on run, you will see that it will pick up Giovanni and the age of 13. And this will appear at the top because I added this expression at the top. So here it says cats and name Giovanni, age of 13 is the oldest cat. Now, of course, if you just want to get the name or anything like that, we can just highlight oldest cat, add a block, and we'll write oldest cat dot name. And it will require this to be nullable. So if we click on play, it should just say Giovanni is the oldest cat. And as you can see, we outputted Giovanni is the oldest cat. And there's actually another way to simplify this. And as you can see, we only have one parameter here that says cats. So Kotlin is quite smart about this, and it can infer that there's only one type here and that it is pointing to cats. So what we can do is remove these two cats and replace it with the it keyword. So this just takes what we're working with and inserts it there. But this video is not going to be concentrating on it. I believe I'll make one more video that will concentrate on it. But for now, you just need to know that this points to the cats class and that you can use it in most cases that you only have one parameter to be inserted for your lambda expression. But with that being said, that's all I wanted to show you in this tutorial. And I will see you guys in the next Kotlin tutorial. Thanks for watching and see you. Alright, so you might have heard of these terms such as let, run, also, apply, and with, and these are called scope functions. And that's exactly what I want to go over in this video. So let's get started immediately by creating our first let function. And to do that, we will write in our function main. We will start with value string. And that's going to equal, let's just say string because I'm not that creative. And right below we will write value string length. And that's going to equal string dot let. And inside here we are going to type in it, which refers to our string up here and this one right here. And we are going to call length at the end of that. Then we are going to print line the string length is string length long. So let me explain to you what I just did here. So of course, first we initialize the value of string with this string text of string. And then we created another value of string length, which takes this string value and it calls .let on it And what is let? Well, let is a function that takes the object it is invoked upon as the parameter and returns the result of the Lambda expression. That means it uses this as the base, and whatever the result of our Lambda expression is, it will assign that value to this part over here. So let's just click on play and see what it does. And you can see string length is 6. That is because there are 6 letters in this string. Alright, so that was the first example. Now let me show you another example on how you can actually chain these let functions. So for this example, we're going to create a var, which is called a, and it's going to have the value of 10, and then right below we'll do var b, and that's going to equal 2. Then we're going to write a equals a plus 2, and we are going to call .let on it. And inside here we can do a few more calculations. The first calculation we are going to do, we'll create a parameter of I, and it will equal it plus b. And this requires that we return something, so we will return I just by typing I down here. So it refers to the object of this let function, which is a plus 2, and it adds b to it, which is 2, and returns I. So I will be assigned to a. So at the moment we have 14, because a plus 2 is 12, and 12 plus 2 is 14. So I will be assigned to a as 14. But we can also take this one step further and add another let, which takes this whole part over here, which is 14, and allows us to add even more to it. So let's do it plus 5. And that means in the end we will have the value of 19, because after having this whole statement that evaluates to 14, we do it one more time, we take this, and it refers to this whole section over here and adds 5 to it. So if we print line a, you will see that we will end up with the value of 19. Great. And up next we are going to talk about the run function. So a run function executes a block of code and returns its result. So let's get started immediately with another example. We are going to write var sentence, and that's going to equal how are you doing? And we are going to print line this sentence. Then right below we are going to type in sentence, and we are going to equal it to run. So here we can execute a code, and of course whatever happens at the end of this block of code will be returned and assigned to sentence. So inside here we will type in value sentence 2, and we will equal that to this gets returned inside the run function. And of course we will print line a statement in here that also says this gets executed inside the run function. And as you can see, we have this error. That is because we have not returned anything yet, so we should return sentence 2. And that will assign sentence 2 to the original sentence. So then when we print line sentence, it will have changed to sentence 2. And if we click on play, you'll see it says how are you doing, because that's what we decided to print line up here. Then we will refer to sentence, and we will create this run block, and it will say value sentence 2, and this gets returned inside the function. And you may have noticed that that's actually at the bottom, and it's not in the order as you see in the block. That is because here we assigned it the value of this string to sentence 2, which gets returned to sentence and then printed later. So the only thing that gets run inside here is the print line statement that we created below. So that is the second thing that happens. This gets executed inside the run function, and then it returns sentence 2 and assigns it to sentence, and we print line sentence, so we get this final string down here. So let's continue with another example, and this one's going to be an example that combines let and run. So we are going to create a var called phrase, and that is going to be of type string, which is nullable, and we're going to assign that to null. And then right below we're going to write phrase, which is nullable, dot let, and inside here we want to print line the phrase is phrase. And then we are going to add what is known as an Elvis operator. So the way this Elvis operator works, as you can see, it's just a question mark followed by a colon, and that means that it will check if the first statement is null, then it will not do anything there, and it will execute the second statement. So it's kind of like a null check. So in case this turns out to be null, then we are going to run a different statement. So we're going to write run, and we are going to assign a new value to phrase, and that's going to equal this was printed because the phrase was null. And we should add a space there. And then we'll write print line phrase. So because we know that phrase is null, we are most definitely going to get this statement printed to us. but I will show you later what happens if we change it with a string. So as you can see, this was printed because the phrase was null, and the Elvis operator took care of that. And now if we replace this with a string, so we will write string as always, and we click on play, you will see because this was not null that it said the phrase is phrase, and it printed it down here, and it also print lined the phrase, which is string. So the phrase is string, string. So that's a pretty cool way you can combine the two. All right, and I'm gonna go over one more of these scope functions in this video, and this is the also scope function. And let's get started with the example. So we will do value numbers, and that's going to equal a mutable list of 1, 2, and 3. Then right below we can go ahead and say numbers and call dot also. And inside here we will print line the list of elements before adding the new one, and we will just type in it because this is referring to numbers. And then you can also add something to this list, so we're just going to type in add 4, and then we can go right below and print line numbers. So the way the Kotlin documentation defined this also function is that when you see also in the code, you can read it as and also do the following with the object. So you write numbers and you also want it to do all of this. And the returned value is going to be this object itself. But let's go ahead and click on play. So you can see right here, the list of elements before adding the new one is 1, 2, 3. And then we have the list printed, which is 1, 2, 3, 4. So we managed to do all of that with also. But anyways, that's all I wanted to show you in this video. In the next video, I'm going to be going over apply and with, which are the final two scope functions that we should go over. And yeah, with that being said, I will see you in the next Kotlin tutorial. All right, so in the last video, we went over the scope functions of let, run, and also. And in this video, we will continue with that, and we will be going over apply and with. So let's get started immediately by creating an example of apply. So to do this, we are first going to have to create a class. So we're going to call this class person, and it's going to take 3 parameters. So it's going to be name of type string, then it's going to take an age of type int, and a city of type string. And inside here, we're going to type in var name, and that's going to equal the name. Then we're going to do var age, which will equal the age, and var city, which is going to equal the city. And we are going to add a simple function that says function introduction, and write print line hello, get out of here, and write in hello, my name is name, I am age, years old, and I live in city dot. Perfect. And that will take care of everything we need in the class. Now we can go back to our function main, and inside here we are going to instantiate the person, and we're going to write value even is going to equal person, and we need to pass some arguments into our constructor. So we're going to write even, and then age of 37, and finally city as Copenhagen. Now let's pretend we want to edit these values. So usually you would write even.name or age, and you would say 27, or even.name and say his name is actually Tom. But this can be quite demanding when you have a lot of values to work with. So a way to simplify this is actually by typing in even and calling .apply. So in here we don't have to ever write even again because it already knows that we're referring to even. So we can just type in name and set that to Tom, and then we can also call age and say 27, and we can also change the city, why not, and say Berlin. And we can also write introduction. And when we click on run, you will see it says, hello, my name is Tom, I'm 27 years old, and I live in Berlin. So it completely overrided all of these arguments, and it only took adding the .apply keyword. So this really simplifies what we need to do when it comes to a lot of values that have to be changed. And you will see in Android Studio that this will become a personal favorite of yours. It's probably the one I use the most. All right, but let's get rid of even. And let's move on to the next scope function. And this one is called with. So luckily we already created a class which will be applicable to this with function. So we can just go ahead and create a new person, value max equals person. And we need to give him a name. So he is Max. He is 77 years old. and he lives in Copenhagen as well. And down here, we're just going to write with, and we are going to write the receiver, which is going to be Max. And inside there, we can write print line, and we're going to add these single quotation marks and write with is called with argument this. And this will refer to Max. So it's just going to print what that is essentially, what is the code of Max. And then let's edit his age. So a lot like apply, you can still edit and change values, and we're going to change his age to 29. And let's also change his name to Luigi. And finally, we will write print line name changed to, and we will grab that name, and age changed to, and then we will also grab the age. So with that being said, we don't have to add a print line statement under. This will just take Max as the receiver and it will print all of this. So yeah, the Kotlin documentation essentially says that this should be seen as in the code, with can be read as with this object, do the following. So we have Max as the object, and with Max, we want to do all of this. And inside the with block, you are more than welcome to return a value, but I don't have to do it here. It doesn't really matter for this context. So we will just go ahead and click on run. And you will see that the first print line will tell you that with is called with argument person at this crazy code. So that is the code of Max, and that is what happens when you create the object of person. And then we have another print line that says name changed to Luigi and age changed to 29. So that all happened inside the with block, and that's practically what you would use a with function for. But with that being said, I believe I've covered everything I had to with the basic 5 scope functions. In the next video, I'm just going to cover one last thing, and that is takeIf and takeUnless and what that means in Kotlin and how to use it. But with that being said, I will see you guys in the next video. Alright, so in the last video we covered scope functions, and this is going to be a small extension on that because I found out at the bottom of the scope function documentation there was this small section that included 2 new functions that I have not read about before, and that is takeIf and takeUnless. So let's get started immediately by creating an example as always. So we'll write value number, and that's going to equal a random number of type int. So we're going to write next int, and that's going to be until the number 100. And of course we need to import the random, so we have to choose this kotlin.random, and everything will be perfect. Then right below we're going to create a program that tells us whether a number is odd or even, and let's go ahead and get started immediately. So the first one we're going to write is even or null, and it's going to equal the number, and we are going to call takeIf on it. And then we are going to refer to the number by typing in it, and we're going to use the modulus operator, and is divisible by 2. Then we will print that it is even. Otherwise we will print null. And an easy way to look at this one is takeIf returns the object if it evaluates to true. So if this is true, we will get the number that was even. Otherwise we will get null as a response. And then immediately under we're going to create value odd or null. And that's going to also take the number, and instead of takeIf, we're going to write takeUnless. So this takes exactly the same Lambda expression as the one above, with the exception that this one, if it prints an odd number, it will still print the number to the console. That is because if it evaluates to false, it prints the number. Otherwise, if it is evaluated to true, it will not print the number. So as you can see, takeUnless returns the object if it evaluates to false. So 57 here will be returned, and 57 here will not be returned. And then we will add a print line statement below. And here we write even, and we will insert even or null. And then we write odd, and we will insert odd or null. So if we go ahead and play this program, you'll see that if the even number turns out to be an odd number, it will not print it to the even side, it will print it to the odd side. Now let's go ahead and click play again. Now you'll see that it is still odd because it is 39, and it will print it because this evaluated to false, which means it will be printed. Now let's see if we can find a even number. So here we got the number of 42 when we generated the random int. So since it evaluated to true, we printed even. Otherwise it would be printed to null. So those are the basics on how to use the takeIf and takeUnless functions. But I can go over one more example just in case you didn't get it. And this one is going to create a value of string, which is going to equal hello in lowercase letters. And that is because we want to create a function that will turn this string all to caps. So let's create a value called caps, and that's going to equal our string. And we're going to write take if it, which is referring to string, is not empty. And of course it must not be empty or else the program will not work. So we have to add the nullable type at the end, and we need to write to uppercase. Then we can just go ahead and print line the caps. So what we did here is we created a string of hello, then we created a value of caps, and we used the string value with the takeIf function to check if it is not empty. And since this evaluated to true, we could finish this statement and we could print it to caps. Otherwise, if this evaluated to false, then we would return null here, which means this whole statement wouldn't exist. So let's go ahead and click on play, and you can see that we capitalized the whole string hello. Now let's pretend we didn't insert anything and we click on play. And you can see that since we wrote nothing in here, it wrote null inside here, which means instead of crashing and not doing anything, it just decided to assign the value of null to caps, and it printed out the value of null. So it's kind of like an Elvis operator in a way, but instead of having an either or else, you will just have the value of null printed if nothing happens. But anyways, that's all I wanted to show you in this takeIf and takeUnless tutorial. I hope this helped and I hope you learned something new. But with that being said, I believe I'm going to move on to coroutines. But that doesn't mean I'm done with the Kotlin series just yet. That is because I'm sure I will find other things that I have forgotten about and that I still have to include in this series. But for now, I believe that's all I wanted to cover for the basics of Kotlin, and I will see you guys in the next video.